According to the song, 3 is a magic number. Well, I'm not sure about that, but what I am sure about is that in the video coming up, you're going to learn completely step by step, with no skipping, how to build a .NET Core MVC REST API using .NET Core Framework version 3.1. We've got a lot to get through, so let's get started. Well, hello, wherever you are, whenever you are. My name is Les Jackson, and where am I? I'm in Melbourne, Australia, locked away inside my home office. And when is it? It's April 2020. So I hope wherever you are and whenever you are safe and well. So as I said in that very cheesy introduction, yes, today we're going to be building completely step by step a .NET Core MVC REST API using .NET Core version 3.1. So we've got a lot to get through, a lot of coding to do, so we're going to jump almost straight into that. I do want to do just a quick introduction just to preface what we're going to do and set the scene for you. Before I do that though, just the usual begging, if you like the video, give it a like. If you haven't done so already, please subscribe, and you'll be notified of all the new stuff I put out. And if you're watching this on Patreon or you've signed up to my Patreon channel, huge thank you to you guys as well. And just a reminder, your names will be appearing at the end of the video by way of a special thank you for all the support. But with that, let's take a quick look at what you're going to be learning, and then we'll move on to a quick demo of the API, and then we're going to begin coding. So I don't want to say this anymore, it's a bit of a tongue twister. This is episode 2, season 3, for those of you interested in the chronology of what I'm putting out. And this is what we're going to cover today. This is the introduction, so as I said, we'll be doing a demo. I'm going to go through everything you're going to cover right now, and then I'll quickly go through the ingredients you need or the tooling to follow along, and then an overview of our application architecture. But we touch base with the application architecture throughout the whole tutorial, so I won't spend too much time on that up front. Coding part 1, we'll create our model and our controller. We'll also create our repository, and we'll talk a bit about dependency injection, and we'll also create our first 2 API endpoints that will respond to GET requests to read data or read resources from our API. Coding part 2, we'll move into talking about Entity Framework Core and specifically create a DB context to talk to our SQL Server, and we'll revisit our repository as part of that. Coding part 3, we talk about data transfer objects. We don't just talk about them, we write some and create some, and as part of that we will use a tool called AutoMapper to make our lives a lot easier. And we'll also introduce our next API endpoint, which responds to a POST request to create resources at our API endpoint. Coding part 4, we talk about put, patch and delete type requests, which are involved in updating resources either in full or partially, and of course delete is quite self-explanatory. And then we move into final thoughts and all that kind of lovely, warm and fluffy stuff. So just before I do the demo, I'm just going to finish this last couple of slides, then we'll move on to the demo, and then we'll launch straight into coding. So to follow along, you'll need a text editor. I recommend VS Code, it's awesome and free. You'll need SQL Server Express or the local DB. You can use any other database you like, and I kind of give you some pointers if you choose to do that, but I recommend for simplicity to use SQL Server as part of this video. Postman we use to test our API. I highly recommend it, it's free as well. If you're doing any type of API development, I guarantee you'll be using Postman, so you may as well get used to it. And I think I've been quite conservative with saying an hour of your time. It probably will take quite a bit longer than that, but set aside an hour at least initially. So let's move on to taking a quick look at the architecture of the application you're going to be building. Now don't worry if some of this stuff doesn't make sense to you, we cover it all as we move through the video. So of course we'll get a program and startup class. We'll be working a lot within our startup class throughout the rest of this project. We'll create a model, and that of course is the N in MVC, and that's just an internal representation of our data, to put it simply. V stands for views. We're not really creating any view artifacts in this project as it's an API. I will caveat that statement a bit later though. We will of course be creating a controller, and controllers are basically the orchestrator of the requests that come in, and they house our action results or our API endpoints when we come on to writing those. So a key piece of infrastructure. Database context, DB context, or the data access layer, which is part of the entity framework core stuff I mentioned, and that basically talks to our SQL Server database. I think of the DB context as a kind of mediator between our internal representation of our models and the database. It kind of maps that down to a persistence layer. Something new in this video that wasn't in my previous API tutorial, I actually introduced the use of a repository. Don't worry if that looks like we're duplicating layers of stuff here. We cover that off in more detail as we move through the tutorial, and I'm not going to talk at length about it here. Again, we're going to be using DTOs, data transfer objects. These are simply an external representation of our internal models out to our consuming endpoints. And of course, we'll have a client, we will use Postman in this case, that will make requests to our controller and get responses back via HTTP, and they will have, in the case of read requests and some other requests as well, a serialized JSON payload, and it will be serialized DTOs that will be getting passed back. Now, if some of all of that didn't make sense to you, do not worry, do not stress. We'll cover it all as we move through. But for those of you who maybe have some semblance of MVC, it should maybe start to make a bit of sense. Just circling back to my commentary about views, yes, we're not specifically creating view artifacts in this project, but you could argue that the JSON payload or the JSON response, or just the HTTP response in general, is a view from an MVC perspective. I'll leave that with you to mull over and discuss at your leisure. So just before we start coding, let's just take a quick look at what you're going to be building. And I'm using something called Swagger, or OpenAPI as it's more commonly referred to today. And this is just basically an automatic view that's been generated for me by actually adding some plugins to the API that you're going to be building. And it just gives you a view of the endpoints that our API will respond to. It's kind of like a self-documenting language. And the really cool thing is you can actually even test it out and try it out. But before we launch into that, what is the API we're going to be building? Well, the use case is this. I don't know about you, but my memory is getting worse. The older I get, I'm getting grey hairs in my beard and less hair on my head, and my memory's not as good as it used to be. And with all the new tools and all the different things that get thrown at you these days as a developer, I often find it quite hard to keep track of all the different command line prompts that you have to type in for things like .NET Core or Docker, or just even, Linux commands to, I don't know, set up a firewall, burn, or any of that kind of stuff. It's way too much for me to remember. So this API is going some way to help with that, and it's going to store command line snippets along with a little descriptive bit of text on what that command line snippet is supposed to do. And we're also going to store what platform or what application that command line snippet refers to. So I can actually tell you, I actually use this. I have a localized version of this API running on my desktop, and I actually use it in real life to recall commands, even for things I use quite a lot. So that's basically the use case. We are going to be using very standard CRUD operations, create, read, and update. So this command here, or first get command, will just get a list of all the command line parameters in our backend. So you can try it out, you can execute it using OpenAPI, and you can see the JSON payload and the response codes and all that kind of cool stuff. We are going to have a ability to create commands with our API, as I've already said. We can get an individual command based on its ID. We can update an entire command or an entire command resource. We can patch specific parts of a command resource, or we can delete the command resource in its entirety. So that's basically our API. That's what we're going to be building. It's a fairly simple use case. I've done enough talking. I think it's time we start coding. All right, so let's kick this off. I'm going to open VS Code to start VS Code, obviously. And I'll bring up a command line within that, and that was just control apostrophe. I'm going to change into my working directory, change into season 3, change into episode 2, and I'm going to create my project in here. So you're probably aware of this already, but for those of you who are not, you can get a list of project templates by just typing .NET New, and that will give you a list of the different templates that you can scaffold up. Now in the last video, well, not the last video, the previous video I did on writing an API, I actually used the web template, which is the empty ASP Netcore template. This time round I'm going to use web API. Now don't worry, you're not going to miss anything. The scaffold code, most of it we're going to actually delete, and there's just a little bit that I wanted to retain. So you're not going to miss any learnings or anything like that. I don't particularly like scaffolded code, but in this case you're not missing much at all. So upkey.NET New, and you just type in the name of the template. I don't know why that keeps jumping. My apologies. You have to move this down. Quite annoying. So web API is the template we want. And then the name of our project, call it anything you like, but remember what you call it. I'm just going to call this one Commander. And .NET Core will go away, and it will build up the relevant project for us, and it will create a folder called Commander. So to open that in VS Code, you can just type code R, name of the folder, and that will open the folder in VS Code, which is rather nice. Now I'm not going to do a deep dive of the anatomy of a .NET Core application. I will cover off the relevant bits as and when we need to. You may get this pop-up here asking you to include any required assets. Just click yes. You'll only have to do that once. One thing I'm going to do though is I'm going to delete some of the scaffolded code that we don't need. So as part of the scaffolding, it created a controller for us called the Weather Forecast Controller. I'm going to delete that because we will create our own controller, so don't worry. I will leave the folder there. And we have one model class that we don't need either, so I'm going to delete that also. Just what I will call out that, you know, there are some really important bits of the application. The program class is basically where our application, that's the entry point and where it gets kicked off. We have a main method, which you'll probably have seen before if you've done any .NET Core C# programming. That then just goes on to creating a host using the create default builder method on our host, and that then calls our startup class. So we're not going to touch program class again, so we can close that down. It is important, but we don't need to do much more with it. The startup class, however, is one of the, for me, it's the central hub of a .NET Core application, and we do a lot of stuff, a lot of work in here to set our application up. Just in terms of scaffolded code, we got this as part of the Web API scaffolding, which basically just means we have access to the configuration API that allows us to read in config, and we'll come on to using that when we come to doing our connection string. So I don't need to type that code in. That's really the only scaffolded code that you would get over and above the empty Web API, aside from the weather stuff that we just deleted. I will talk more about both the configure services and configure methods as we move through the project rather than doing it here. Configure services, the name's quite self-explanatory though. That's where we add services that we want to use throughout the rest of our application. We're doing a lot of work in here later, so I'm going to leave it there for now. And our configure method is where we set up our request pipeline. So request pipeline is made up of multiple bits of middleware. Each bit of middleware has a function, and it may or may not pass on the request further down the chain of middleware, or it may short circuit it and pass the request back. The order in which you add middleware is important. And again, I'll touch on the relevant bits of middleware that have been added here by default, but we'll cover that as we move through the project. CSproj file is where we set up or any references to packages that we need. We'll cover that later. App settings JSON is where you can set up additional config. Our connection string will go in here. App settings development JSON is exactly the same. It's just a development version of the same file. and will only be used in a development environment. Again, I'll come on to that a bit later. And the last file I want to talk very briefly about is launch settings JSON. That just sets up a number of profiles. When we start an application, it will start it off on a particular URL, as you can see here, 5001 and 5000 for HTTPS and HTTP, and you can also see here it's setting up our development environment, our environment as development, should I say. Enough of that. We'll cover it as we need to, as we move through the app. So the first thing we want to do is create our command model. So again, models, if you remember, are our representation of domain data within our application. So I'm going to create a folder called models to hold all our models. We're only going to have one though. It's a relatively simple app in that respect. So select the models folder you've just created and click on new file, and I'm going to call our model command. Don't forget to put CS in to denote it's a CS file. And we'll get started quickly by defining the namespace, which is the name of the project, then the name of the folder that this particular class happens to be in, and that is models. Cool. And then we'll define a public class. The models are typically fairly, well, in this instance it's a very, very simple class. It's not terribly complex. It will evolve over time, as you will see. But public class command, and it's going to want to put commander in. I'm not going to allow it though. And then within our command class, we're just going to define a number of properties, 4 in total. And they are, now a little tip, if you type prop, you'll get this code snippet. Just type tab when you type prop, and it will define this sort of template. It is going to be an integer in this case, which is cool, and we're just going to call it ID. Then define a second property, so again prop, tab, this time it's going to be a string, and we'll call it how to. And then a third prop, again it's going to be a string, and this time we'll call it line. This is going to be the command line snippet that we're going to store in our database. And then finally, we're going to store another string, and this time we'll call it platform. And that will be the application or platform that our command line relates to. Now, just a very quick sidebar. I'm going to do a follow-up video where we're going to have multiple domain objects, parent-child objects, and in that video I will pull out the platform into a separate domain class where it will be the parent object and it will have a number of related command objects as children. I decided to leave that out of this video because if I included it, the video would just be way too big. So I'll do that next time. However, everything else I will cover in this video in terms of REST, resources, repositories, all that cool stuff. So just a little sidebar. There will be a next video that will follow on from this one, but for the moment we're just going to leave that as a string as opposed to a reference ID. And with that, our first and only model is complete, and I think now we will move on to looking at building out our repository. So we're going to move on to working with a repository now, and just a quick sense check of where we're at. We don't have a controller anymore because we deleted the scaffolded one. We do have our program and startup classes, cool. We don't have our data access or DB context class yet, which we will come on to in a minute. And we do have our model. So we've got our model, we've got some of our other bits and pieces, but what we're going to do next is create a repository or our repository interface. So just clear that down and go back to our application. Now for our repository code, I'm going to create another folder in the root of our project. So in VS Code, click out of the whatever folder you have selected into the root, just click on new folder, and I'm just going to call this data. You may see it called something else in other tutorials that you watch, but this is my naming convention. And the first thing that we're going to create by way of setting up a repository is an interface definition. Now, this is a really important concept, and it's a theme that's going to run throughout the rest of this video. And by that I mean we're going to have multiple contracts that will exist in different parts of an application. And the whole idea of providing a contract or an interface is effectively what you're saying is, here you are. I'm going to make this deal with you that I'm going to provide this to you. And what that means is, if you define that contract, you shouldn't typically break that contract because that's bad news, basically. And the way we're going to define that contract here for our repository is define an interface, which is basically just a list of definitions, or it's an interface definition, basically. And then we can implement that interface as we see fit, depending on what technology we want to use from a persistence perspective or not. So the idea is that the consumer of this interface doesn't really care how you've implemented it, just so long as you have implemented it. And that leads to a nice decoupling of implementation from the contract that you're providing to your end users. And that's a theme that's going to run throughout the rest of this video. So by way of a repository, the first thing we're going to create is an interface. So in our new folder, let's make sure that's selected, click on new file, and interfaces within C#.NET always begin with an I. And as this is an interface for our whole application, I'm just going to call this I Commander Repository. In fact, I might just call it repo, just to be a bit shorter, rather than typing repository all the time, and I'll probably spell it wrong as well. .cs. So I Commander Repo CS. Cool. Now again, define the namespace. We're in the Commander namespace, and this time we're in data. So to define it, relatively straightforward, public interface. And you can see there, I just click tab on the available shortcodes that came up. It will provide the name of your interface with a capital I, and then you give it a name. So we're just going to give it exactly the same name as our file. So Commander Repo. No CS, obviously, because this is not a file. And then all an interface is just a list of the method signatures that you're going to provide to the consumer of this interface. And then how that gets implemented, I'll come on to that in a bit. So just thinking logically, we are building a REST API that's going to perform the typical create, read, update, and delete operations. So our repository should kind of mirror those operations. You can add other stuff in there if you want, but I'm just going to keep it relatively simple and do some CRUD operations. And I'm going to start with reading, as that's typically a lot simpler than doing operations that actually change our not a repository, change our resources in the database. So the first one I'm going to create is, or the first method signature I'm going to create is give me a list of all our command resources, or all our command objects. And to define that, you have to define an IEnumerable as the return type. And it will complain because we don't have the relevant namespace in yet. That's okay. And it's going to be of type command. Again, it will complain because we don't have that namespace in. And you just give your method a name, get all commands, and we're not going to pass anything in. Now, as I said, it's complaining, so the first thing we'll bring in is IEnumerable, which is, again, hover your mouse over the complaining artifact, hold down Control and period, and that will give you a list of potential resolutions to your problem. So yes, we're going to put that using statement in, and it will complain about command as well. Again, Control and period will bring in use commander models, which is the one we want, and that should resolve itself. And that is it. We don't implement anything in the interface. We're just defining the operations or the methods that are available via this interface. So that's the first one. And the next one will be to return a single command back to the user based on an ID that they're going to provide. So return type is command. Name of the method will be get command by ID. And we are going to pass in an integer of ID. Again, that's it. And I actually struggled a bit with defining interfaces in it originally, because it was like, well, where does the implementation go? Don't worry, we'll come on to that. Now, our interface will build out as we move throughout the video. That's all we're going to do for the moment. We will add more methods to it as we progress through, but we're just going to do it bit by bit and build it up. So those are two fairly straightforward, fairly simple commands that our repository should provide to any consumer of our repository. Fantastic. So we're going to create an implementation of this interface now, and we're going to put it in exactly the same place as the interface definition itself. So select your data folder and click New File. And we're going to call this mock commander repo.cs. Don't forget the CS. Namespace, commander data. And this time we are actually going to create a class that implements that interface. So public class, call it mock. And I'm being really careful with my typing here because I don't want to go back and have to change it. And that is going to implement our interface. And how do we do that? Well, after the class name, you put a colon and then the name of the interface that you're going to implement. And you can see here that we're going to implement iCommander repo. Fantastic. Now, if you used inheritance before, it's a similar syntax to inheritance. This isn't inheritance. We're not really inheriting from anything. We're implementing something. Don't worry, we will come on and use inheritance a bit later on. Now, straight away, you can see that we've put this interface name in here and it's complaining. Why is it complaining? Well, it's complaining because we've not yet implemented any of the methods that we have specified in our interface. So if you're saying, I'm writing a class, it's going to inherit, or not inherit, it's going to implement from the interface, then you have to implement the methods that's specified in the interface. So control period to implement your interface, and you can see straight away it's put in a couple of placeholders that map back to our interface. And it's also brought in a couple of namespaces, which is very, very helpful. So what we need to do now is actually implement these methods. Now, this is a mock repository, so we're not going to connect to a database or anything with this class. We're just going to put some hard-coded data in, which can actually be a useful use case when you come to testing and stuff like that. And again, this separation of interface from implementation assists with decoupling code. So again, when we come to actually using this interface, our application is just going to ask for an implementation of the interface. It doesn't care how we've implemented it. It doesn't know how we've implemented it, and it doesn't care. So again, decouples code from our contract, implementation from our contract. So back over here, let's implement this first. Let's implement the simpler one first. And all we're going to do is we're just going to get it to return a new command, and we're just going to hard code some values, and it's really quite as simple as that. So with an ID of 0, how to string of, I don't know, boil an egg. This is not the type of stuff we're going to put in our API. I'm just putting some sort of joke data in. Line will equal, I don't know, boil water. And our platform will be, I don't know, a kettle and pan or something like that. I don't know. Fine. Semicolon at the end there. Now, as you'll appreciate, when we call this method, yes, it will accept an ID, but it's not going to do anything with it. It's not going to do a lookup or anything. It's just going to return back this command object. Very straightforward. Okay, and then we just need to do something very similar for our get app commands. This time we're just going to return a list of mock command objects back. So let's declare a variable, we'll call it commands, and that's a new list of command objects, curly braces, terminate with a semicolon, and then all I'm actually going to do, and I don't like doing this, is I'm just going to copy this line here up to here. I'm sure you don't really want to see me type that in. Put a comma after it, paste another one in, put a comma after it, paste another one in. We'll only have 3. Let's just change the data a little bit just to make it a little bit more realistic. I don't know, cut bread. That's kind of a random one. How to cut bread? Get a knife. Okay, and the platform is, I put way too much thought into this knife and chopping board. Oh my goodness, should have just done something realistic. And then boil an egg, cut bread, I don't know. make cup of tea. Being British, you know, we drink a lot of tea, so let's see, place tea bag in cup, and the platform will be kettle and cup, actually. Fine, cool. So probably a lot more detail into that than I had anticipated, but you get the idea. And then of course, still complaining, we have to return back our commands. Fantastic. So again, labouring the point, this is a mock repository with fake data, very fake, rubbish data that's not going anywhere. That's okay. That's actually, we're proving the point of what a repository should be, and we'll actually eventually come on to doing a proper implementation of our interface, actually connecting into a database, obviously. So cool. So we've done our mock repository based on our Commander repository interface, all good. So now we want to come on and actually use it in our application, and the way we're going to do that is actually by creating our first controller class. Okay, so we've already got a controllers folder from when we scaffolded our project, so we're just going to select that and create our new commands controller in there. Now you'll typically have one controller per resource type, so we're dealing with REST, we've got a command resource type. If we had another resource type such as platforms, you would have a controller for platforms. So it's not like our repository interface where we're having an interface for an entire project. Our controller is at a resource level. So we're going to create a controller class for our commands object or our commands model. So select the controllers folder, click on new file. We're going to call it command, plural, controller, commands controller. And you'll typically, it's good practice, or you'll usually see the resource type that you are building a controller for will be pluralized as opposed to the model, which would be singular. So you'll see our model was called command. Our controller for our command object will be called commands controller. All good. Okay, I'm just going to, I was going to clear that, yeah, let's get rid of these just to give us a bit more, just to make it a little simpler. So first thing as usual, namespace. We're in the Commander project and we're in controllers. I think it would be really nice if VS Code picked up this name from scratch. It will do it next time because we've already added it manually, but it didn't the first time round. The first time use it doesn't. Okay, and we are going to create a public class, and we're going to call it commands controller. Okay, now it gets a bit more complicated than this, and I was talking about inheritance in the last section, and this class is actually going to inherit from a base class called controller. Controller base actually, and it will complain. So let's bring in the namespace using a Microsoft ASP.NET Core MVC, and the controller base class, as it says there, is a class for an MVC controller without view support. We're not having views in this case, in this project. You could just inherit from controller and that would bring in a MVC controller with view support, but we'll leave it as base. You want to, in the same way when you're defining security permissions, you want to include the least amount of stuff in your application as possible to make it simple and as lean and as efficient as you can. Cool. Now the first thing well, maybe it's not the first thing, the next thing we want to do is decorate our class name with an API controller attribute. Now what that does is it gives us some out-the-box behaviors that our controller will perform, and I'll call those out as we move through the video. Not mandatory to do this, but it makes your life a lot easier if you do this. You'll get, yeah, as I say, some default behaviors out the box. And then the other thing we want to define is a class level or a controller level route. Now the route in short is basically how do you get to the resources and how do you get to the API endpoints within your controller. And in this case, we're going to define one at a controller level, which gives us our kind of base route to our controller. And then if, as and when required, at our API endpoint or action result level, we may add to that route. And if that doesn't make sense, you'll see what I mean when we come on to doing that. But for now, we're just going to put our string in here, and we're going to have API. Now you could put in square brackets and then the name of, just actually type controller. And what that will do is the route will, in our case, just comment it out, would be API commands. Because what this does, it takes this string out and it pops it in here, basically. So you would have the route to our API, well, the base route would be API commands. Now, what will happen if you change the name of your class, this route will change as well. Now, that might be the behavior that you want. It may not be. Again, coming back to having a contract with people, I wouldn't be too keen on having the name or the route of our API changing if we decided to change some implementational detail. So what you can do, and what I'm going to do, is take out that kind of wildcard approach and just put in a hard-coded string that won't change even if our class name changes. But it's up to you. You can use either methods. That's totally fine. Fantastic. So we want to create effectively our API endpoint. So let's quickly pop back over to our PowerPoint here. And we're going to implement all of these endpoints as action results in our API controller. Now, just one thing I want to draw your attention to, you'll notice that if you just look at the URI component for the first endpoint and our third endpoint, they are identical. So you might go, well, how, when we call that URI, how can we differentiate between what will ultimately become two separate action results? How does ASP.NET Core application know how to differentiate between the two of them? It differentiates between the two of them based on the verb. So the verb taken in conjunction with the route or the URI should be unique. And you can see that is indeed the case. These URIs are all exactly the same as is this one, but they are different because of the verb that they respond to. So I just want you to bear that in mind when we come to creating our action results. Also just bear in mind the success codes that we want to pull back for our two read endpoints that we're going to implement now. So back in our controller class, we are going to create our first action result endpoint, which will relate to getting all of our resources. So public action result. What does it return back? It returns back an I enumerable. Enumerable of what? It will return back an I enumerable of our commands, not pluralized, and it keeps wanting to put in the name of the project, which is fair enough. And we can call that anything like get all commands. And it will start complaining on a number of fronts, first being that it doesn't know what this is. So again, control period to bring in that using statement, and it doesn't know what this is at the moment, so control period to bring in models. And it will complain because this isn't returning anything back yet, which is okay. Let's just quickly write up the shell construct for our next action result, public action result. What's it returning back? Again, this is just the one where we're returning back a single resource. In this case, it's a command. And we can call it anything we like, get command by ID, and into that we'll pass an integer. Call it anything you like, we'll call it ID. Okay, cool. And that's complaining as well, clearly because we're not returning anything back yet. Now, what we need to do in order to say this action result, and indeed this one, are going to respond to HTTP GET requests is by decorating each one with HTTP GET. And likewise for this as well. So that resolves that issue of how do we know which action result is going to respond to which. And again, looking at this base route should look quite familiar. This is what both of these at this point in time will respond to. Now, as I said, the URI or the route in combination with the verb needs to be unique. Now, currently, these are not unique. They're both responding to the same URI and they're both responding to GET, which is not what we want. So, in fact, we need to change this one just a little bit, because when we come to calling this, the way we're going to call it, going back over to our PowerPoint, not postman, that is by supplying an ID. So it wouldn't be that string exactly, it would be something like 1 or 5, whatever, to denote the ID of the command that we want to pull back. So the URI for this one is actually going to be different, even though they're responding to the same verb. So the way we do that is by going back into here. There's a number of ways you can do it. You can actually add a new route statement above this, or you can just append it in here, which is what I'm going to do. And it's round brackets, double quotes, and then curly brackets, ID. And what that effectively does is that then gives us a route to this action result that's a GET request that will respond to this URI. If I can get the fingers going, and whatever the ID happens to be. And again, this would actually be a number. Microsoft seemed to use the number 5 to denote URI of that type, but that is now what this one will respond to. So these now are two different endpoints responding to different URIs, although they are using the same verb. Cool. And I'm actually maybe just going to leave that in here because it's quite nice documentation, I think. And maybe just for this one here, it's going to respond to GET, obviously, API commands. Although once you get used to this, you will not need stuff. You will not need a comment like this to understand what they're doing. The code is self-documenting. So again, they're complaining. So what we want to really do is make use of our repository to pull back data and present that back to the user. So what I'm going to show you here actually is, well, I wouldn't say it's not the right way to do it, but it's not the optimal way to do it, and it's not going to leverage the benefits of having an interface and separating out that implementation from our interface. But I'm going to go back and show you the way that you may have made use of something like our mock repository class to return data back to an application, and we'll then swap it out for a better approach. So I'm just going to create a private read-only instance of our mock commander repo, and we'll call it _ repository, and then we'll use the very familiar equals new mock commander repo, which will instantiate a concrete instance of this actual class. Now it's complaining because it doesn't know where it is, and we'll bring in the relevant namespace so it stops complaining. So we want to basically make use of this repository now in our get all commands action result to return back all our commands. So I'm first of all going to create a variable to hold our result. So command items equals repository get all commands. Cool. And then we want to return that list of commands back with a 200 success, so return OK, and in this instance I'm selecting OK. If we were doing some other logic in here to return back some other result, you have all sorts of other HTTP results that you can handle back. I'm just going to use OK for 200 success, and I'm going to pass back command items. Cool. So coming down here, we're going to do something very similar. We're going to create a variable to contain our single command item. And that's going to come from our repository. And that's going to be our get command by ID. Now we need to pass in an ID. Where are we going to get that? We are going to get that from here, from the ID that's passed in to our action result. And we are going to return that back as well via a 200 OK. And we're going to pass back our command item. Now, just one question that you probably have here is, okay, where does this ID come from? Well, it actually comes from the request that we pass in via the URI. So when we use Postman to call these endpoints, we'll pass in an ID, and it will actually be resolved from the URI. Now, that actually comes from something called binding sources. And there are a number of binding sources that you can have. And again, because we've set our controller up in the way we have and we've decorated it with API controller, so on and so forth, there are certain default behaviors that it will give you out the box. And so in this instance, when we call this endpoint via something like this, the ID will be derived directly from the URI. So just coming back to here, you can have binding sources from query, from route, from form, from body, from header, and they relate to different places in our request where data could come from, and there are certain default behaviors that we get with .NET Core. Now I will call these out as and when we may be using a different binding source, default or otherwise, to obtain data. But for now, all you need to really worry about is that this ID is going to come from our route, as we've specified here, and that will be passed in to this action result and will be resolved here. Now, I'm sort of going off on a tangent a little bit, and I've showed you how to do something not the right way, but let's just see if this all works, because this is a good touch point just to see if we're on the right track. So make sure you have saved everything. I've fallen into that trap numerous times where you don't have something saved. We'll do a .NET run to run it up. Fantastic, and let's go over to Postman and call both these endpoints. So already have one running here. Let's try it again. So base URI, which is just the web server that it's running on. Here's the route to our controller, and we're not passing anything else in. We've set the verb to get, so what that should mean is it should hit our first action result, which is, let's move this down a little bit, this one here. So we've already got our route specified at the controller level. There's no additional attributes. We've decorated this with HTTP GET. So as we'll flip back to Postman in a second. When we make that call, it should hit this endpoint and return all our command items. So let's try that now. And indeed it does. And more importantly, it returns back the status of 200 and our hard-coded array of objects. Now, we can put in a different URI, and again, as you will remember, our mock repository doesn't do anything with this ID. It should just return back a single object, and in fact it does, one with ID of 0 in this case. But again, you could type in any integer here and it's going to work. Okay, so that's all working. I hear you say, can we move on to doing something else now? Well, not quite. And the reason is this. Our code base at this point in time isn't that big. However, we have still used a concrete implementation of our mock repository class within our code base. Now imagine down the line, our code base has grown, we've used this same approach everywhere, and we're making use of the new keyword and the actual name of our class. If you then wanted to change that implementation and use something like a SQL Server implementation of a repository or an Oracle implementation of a repository, you're going to have to go through your code base and not only replace the code, but you may not be sure that it's going to provide the same behavior. So what we're going to pivot to now is, instead of asking for a concrete implementation of a class, we're just going to ask for an implementation of our interface. And we can then, at the back end, using dependency injection, swap out how we implement that interface, and our commands controller class in this case doesn't care how we've implemented it. As long as we've implemented the interface according to the contract, that's all it cares about. And we can then have a relatively strong degree of confidence that if we've implemented according to the interface, that we're going to get a consistent result set back. And we don't need to know how it's been implemented. And if we do need to change the implementation, we only need to do it very simply in one place. And I'm going to show you how we can do that. So just before we start coding, I thought it would be worthwhile just doing a couple of quick slides on how the dependency injection system hangs together in .NET Core, as I think it will help you when we come to doing the coding. So we begin with something called a service container. Now, the service container is configured by configure services method in our startup class. So you should remember that from maybe about half an hour ago. And that is where we set up effectively registrations. So as you can see on screen there, what we're going to register is we're going to say whenever anybody asks for our iCommander repo interface, we are going to give it some concrete implementation. And in this case, as you can see on screen, we're going to give it initially at least our mock commander repository implementation. And what that means is we configure that one time in one place in our startup class. And if we then 6 months down the line or 2 months down the line or whenever down the line we would need to swap out the mock repository for a real repository, we just need to change it in that one place within our service container. And so within the rest of our application, whenever our application asks for an instance of our iCommander repo, it will get given the relevant concrete implementation. And so the rest of our code doesn't need to change. So that's the power of it. That's the decoupling aspect coming into play. So in reality, how that works within our commands controller class, we're going to create a constructor. And into that constructor, we're going to expect an iCommander repository instance. And at that point, when the constructor is called, the dependency injection system will inject whatever dependency we have told our service container to provide whenever anybody asks for iCommander repo. And so at that point, our commands controller will actually get a mock Commander repo instance to play with. That's it. Now, one last slide. I just wanted to cover this because if you've not seen it before, you might be going, what is this? Let me just bring them all up. There are 3 ways you can register your services within the service container: add singleton, add scoped, and add transient. There's lots of documentation on Microsoft's website and elsewhere, like on Stack Overflow, that goes into the low-level detail of why you would use one over the other. I've put some high-level categorizations up there. Add singleton, you will get the same object for every request. Add scoped, you will get a new object for every client request. And transient, you will get a new instance every time one is requested. So we're going to use add scoped when we come to doing our registration. So I just wanted to preempt that conversation here. And when I come to doing it in the coding, you'll know what we're doing. So with that, let's go over and start coding. Right, so we're back over in our startup class, and specifically we're in our configure services method where we're going to add our registration. So again, we'll make use of our services collection, and this is where you'll pick up the add scoped, add singleton, transient, so on and so forth, but we're going to do an add scoped. And then it's very simple. Open angled bracket, and then you just tell the dependency injection system your interface. So in our case, it's iCommander repo. And what's it mapped to? It's mapped to our mock Commander repo. Now, it's not going to resolve these at this point, so assuming I've spelt them correctly, it should bring in what we need, so iCommander data, and that looks good. So that's it. That's all you need to do in the startup class. That's all you need to do in configure services. We're just saying, basically, whenever our application asks for one of these, give it one of these. Now, if this changes somewhere down the line, and it's going to, all we need to do is swap this out. The rest of the code elsewhere in the application should remain absolutely the same. So it's very powerful. So we'll save that off. That's us added the necessary bits and pieces to our startup class, 1 line, not much. So moving back over to our commands controller class, you will remember the first thing I said we need to do is create a constructor in order for that dependency to be injected. So CTOR to create a constructor, tab to take us to our parameter list, and we're going to ask for an iCommander repo. And we're just going to call that repository. Cool. Fine. Now, what I actually also want to do is I want to rem this out because we're not going to use that anymore. And what we're going to say is whatever is injected via the dependency injection system into this value here, we want to assign it to underscore repository, and we'll make that equal to repository, close, semicolon. Now it's still complaining because our underscore repository hasn't been created anywhere, so control period, and we will select this second one here, generate a read-only field. And that should resolve. Now, that should all work. Now, before we go on to test it, one thing I want to say, when you're using dependency injection, you will see this pattern repeated time and time again, and we're going to use it again. And by that I mean, we'll have a controller, we'll have some attributes created here, we'll have some private read-only fields here. I'm always going to use an underscore to denote those, and we will then assign the dependency injected value to our private field for use within the rest of the class. You will see that used time and time again, and you'll see it in examples out there in the real world. Now, Assuming I've done everything correctly, unless I've forgotten something really obvious. I don't think I have, but let's run it and find out. If I have forgotten something, it will sure enough complain. Everything's saved, so .NET run. And back over to Postman. And we should run this and we should get the same result. And in fact we do. Fantastic, let's just check that out. Put in our arbitrary integer. Fantastic. So the code is running exactly the same as before, but we're now using dependency injection and we're now using our repository the way it was meant to be used. Fantastic. So give yourself a round of applause. We've hit quite a big milestone here. The next part of the tutorial, we're going to pivot away from repositories just slightly for a moment, and we're going to use Entity Framework to actually set up a connection to our physical data store, and we're going to use a database context in which to do that. So that's coming up next. So just before we move on to doing any coding, I'm just going to do a quick sense check of where we're at. You should be familiar with these things now, so I'm not going to go over them again. The controller's still a work in progress, but what we're moving on to now is this data access or DB context class, which is part of the entity framework. And as I said previously, it acts as a mediator between our physical between our physical database and our models, and in fact the rest of the application. Now, as I said previously, in my last example, the controller talked directly to this. We are now putting a repository in between, which you should be starting to get familiar with now. But in this next section, we're going to go over SQL Server just a little bit. We're just going to make sure that's all set up correctly, and then we're going to go on and start doing our database context class. So let me just kill that for the moment. And the first thing we're going to do before we move on to even coding is just to bring up and make sure that we've configured our SQL Server correctly. Now, the tool I'm using for this is SQL Server Management Studio, which is free to download. It is only available on Windows though. If you're using Visual Studio, you have a kind of version of this built into Visual Studio. If you're not using that, then you can use the command line to do everything we're going to do here. I'm not going to go through that in this video, though it just take too long. So my SQL Server is running on localhost. It's running on a non-standard port, 4444, so I've just put that in, and you'll notice there's a comma there as well. If you're running on the standard port, which would be, I think it's 1433, you don't need to put that in. SQL Server Authentication is selected. There are a number of other types of authentication mechanisms, Windows, and then a number of Azure authentication types, but we are using SQL Server. I'm going to log in with the SA account in this instance, which is System Administrator, which is the kind of God account. When you install SQL Server, you'll be asked to provide a password for this, so hopefully I can remember mine, and we'll log in. That will just bring up your SQL Server instance, which is here. I'll park that for the moment, the update. And then within each server, you can have multiple databases. Now you'll have a number of system databases, which we're not going to touch. And then I have a user created database here for another project that I'm working on, which we're not going to touch either. So you will notice there is no database for our API yet. That will get created later. So the only other thing I want to do is create a dedicated account for our application to use to log in and do all its work, rather than using something like the SA account, which you would never do, although I have done it in previous tutorials, but I'm being good this time in taking that extra couple of minutes to create a specific login. So expand the security folder. You don't need to expand logins, you just right click it, new login, and we'll call this Commander API. And I'm going to make sure I remember that. In fact, I'm going to just copy it and just paste it into a little notepad over here so I remember what it was. And I'm going to give it a password. Cool. I'm going to take this off, although I think I have hit password policy, maybe. Not going to give it any default date. Well, there's a default database there, but we'll just leave it at that for the moment. And the only other thing I want to do is give it a server role. I'm just going to give it sysadmin, which is more than you should give it, but I just want this to work kind of first time without messing around too much. But that's something you should probably go back and revisit in a real life scenario. I think other than that, we're all good. So click OK, and that should go away. And if we expand this now, you'll see there it's created a login. So the only thing I want to do, and this is a really important step, and I advise you all do this, is disconnect and reconnect in with that user. I've had a number of questions on previous tutorials where people were having trouble from the code and saying my code isn't, from the application, I can't connect in. And the first thing I always ask them to do is check that you can log in to the SQL Server from a tool separate from the code that you're working on. And more often than not, that's where the issue has lied. So our login was Commander API. I'm just checking that that was the case, and hopefully if I type in the correct password, it connects in. So that's cool. We know that our new login is all working. We can connect in, we can see our databases. That's good. So we're set up and ready to move on to the next step. So let's just, we don't need that just now. Let's just minimize that. So back over in our project, what we need to do before we do anything else other than, aside from coding, is add some package references to our project that will enable us to use Entity Framework. So the way I like to do this is just to bring up a terminal, and I'm going to do it from the .NET Core CLI. I've brought up our CS_proj file because as we use the CLI to add packages, you'll see them being added into the CS_proj file. I do that just as a kind of double check. So let's go. I just want to show you the packages we are going to install. So let's just bring up NuGet again. Just bring that over. It's on my other screen. My apologies. And the first package we're going to install, let's just search for Entity Framework. The first one we're going to install actually is this one here, Microsoft Entity Framework Core. And if you've not used NuGet before, I'm sure you probably have, you get different methods of installing it. We could just copy this text and paste it straight into our CS_proj file. I don't like doing that. I would much rather run this command at the CLI and then see the package reference being added in to our proj file. It's just a little, for me, a nice little double check that we've done it correctly. So I'm actually going to take out, I don't want to use the preview version, I just want to use the latest version, which you will get if you don't specify a version. So let's hit enter, that will go off and pull the package down, and then you'll see it being added to the CS_proj file. The next one we want is the design, so this one here. Let's copy that and paste that in here. Let's just clear this just so you have a bit more, it's a bit more readable. And I'm deliberately going to make a mistake here. This is what I'm talking about. Say many times I've done something like that, not copied the string correctly, hit enter, and I've not really been paying attention, and I've kind of looked at the command line going, okay, that's cool, that's worked. But you can see here it didn't actually add the package reference, and if you look at the output, it is actually an error. But if you're not paying attention, you might not catch that, and that's caught me out a few times. So that's why I like to do it this way and watch the CS_proj file being populated with the package reference. So up key, I'll add on the N, and it should this time work. There we go, and it adds in a number of other stuff. So you know that's working, you've added it correctly, so it's all good. And then the last one we want to use is, because we're using SQL Server, there's another package for SQL Server. I don't know if it's on here. It will be here somewhere, but we'll just type it in. It's fairly straightforward. So it's basically exactly the same as the other references we've been adding, except we just add on SQL Server. And well, let's check that we added the right one, and we should see it being added to our CS_proj file. There we go. Now, it's at this point here, if you were using something like Postgres or MySQL, you wouldn't add this package, you would add the relevant package for your provider. Awesome. So that's our package references set up. The only other check I want to make is we're going to use something called the .NET, the Entity Framework Core toolset, and that will allow us to create and generate something called migrations, which I'll come on to in a minute. But I just want to make sure we've got the tools set up and running. So .NET EF, just to check that you have the tools up and running, and you should see something very similar to this. You'll get a little unicorn, it'll give you a version of the tools, all that kind of stuff. Now, if you don't see that and you get an error, then I'll just copy and paste this over. I'll put this in the, well, you can look at it on the video here, but I'll also maybe put it in the video narrative. If you don't see that, then just run this command here, .NET tool install -- global .NET-EF, and that will get the tool set. If you're running an older version of the tool, say you're running 3.1.2, then you can, instead of using install, you can replace that with update, and that will update you to the latest version, which you may get that complaint. Anyway, we don't need to do that, that's all working. So we're ready to go. So what we want to do now is actually create our DB context class. And so back over in our project, I've just cleared down a number of open windows that I had here just to give us a bit more breathing space. And yes, we're going to create our DB context, which you'll recall from our architecture overview. You may see it placed in the models folder. I'm not going to do that in this instance. I'm going to put it in with our data components. So just right click, data folder, new file, and give it a name. Call it commander context.cs. Did I spell that correctly? Yeah. Awesome. And then we'll just specify the namespace as usual. Commander data. And then we'll declare the class public class. Commander context. Now, what we actually want to do here is inherit from a base class called DB context. And it will complain because it doesn't know what the heck that is, so control period to bring in the relevant namespace, which should look familiar if you were paying attention in the last section. And the first thing we want to do is define a constructor, and we're going to actually use the base keyword to call the constructor of the derived class, which is the DB context in this case. So public, actually let's use the nice short code ctor command context. The parameter we want to pass in are some options. So DB context options of type commander context. OPT, and then we'll use the base keyword to actually call the constructor from our DB context, and we'll pass in those options. Cool. We don't need to put anything in here at the moment, and I don't think we do for the rest of the tutorial, but we need to set this up anyway. So the next thing we need to do, which is probably a bit more interesting, is create a representation of our command model in our database. And the way we do that in Entity Framework is to use a DB set. So we define that as a property in our class, so prop tab, and it's a DB set of type command, and we'll give it a name, commands, and that you'll notice is pluralized. Cool. Now it's complaining about command as it doesn't know what that is, so control period to bring in the using statement. And that should resolve. And that's basically it. So just to go over what this is again, this is basically saying we want to represent our command objects down to our database as a DB set, and it's going to be called commands. Now just remember this name here, and you will see it reoccur throughout the rest of the project, and in one place specifically that I won't call out right now. And that's it. Now just to again labour the point, if we had more models in here, we could add other models in here, so platform and users or whatever, loads of different models, but unless we add an associated DB set within our DB context, those classes won't be mapped down to our database. We need to do this mapping here. Okay, so we've got our DB context, awesome, we've got our database, awesome, but at the moment there's still a disconnect between the two. Our application doesn't know about our database, so we need to rectify that clearly, and the first step in doing that is to tell our application where it can find our database, and we do that through a connection string. The name is fairly self-explanatory, so don't think I need to go into too much more detail, but it just basically has the configuration elements such as hostname, IP address, user ID, all the good stuff we need to connect to our database. We can configure the config for our application in a number of places. I'm just going to put it into app settings JSON. If you wanted development specific connection string, you could put it in app settings development JSON, but we're just going to use the main app settings file. That's fine. So put in a comma to denote that we're moving to a new JSON item, and we're going to specify the key here. We'll call it connection strings. Now you could call this anything, but you would then have to reference the connection string in a slightly more long-winded way when we come to doing that from within the code. If you use this string here, connection strings, again it's kind of convention over configuration. The Entity Framework core framework knows that our connection string is going to be contained here. If that doesn't make any sense, I'm probably not explaining it very well. You'll see when we come to referencing it in the code what I mean. Colon, and then another pair of curly brackets, and you can add in a number of connection strings. You might be connecting to multiple databases. We're just going to be connecting to one. So double quotes again. You can call this anything you like. I'm just going to call it Commander Connection. That's our key. And then the value is going to be our actual connection string. So I am going to, no, let me type it in. I was going to copy it in, but let me type it in. So the first item we want is our server. And that will just equal the localhost, comma, 444 that I used previously. And obviously you would put in your host name or IP address of where your SQL Server resides. Configuration elements are in a Microsoft SQL Server connection string are delineated by semicolons. Now that's another good point. This connection string is specific to a SQL Server. It will change if you're using a different database provider. So if you're using Postgres or Oracle or MySQL or something like that, your connection string will look slightly different, and you'll need to do a bit of Googling to see what that connection string would look like. So package provider that you add into your CSproj file would be different, and then the connection string would be different, and then the last bit of coding we need to do would be slightly different as well. If you're interested in how to do it for Postgres, I do cover that in my book, but to be honest with you, it's quite easy to find it on Google. So that's our server component. The next thing we want to specify is the database we want to use, and SQL Server, you can specify that using the initial catalog key, and we can call it anything we like. I'm going to call it Commander DB. Now you'll remember from looking at SQL Server, we have a database in here. That's a database I created for something else, but we don't have that database in here yet. That will be created at some point. So that's really the name of the database here. And again, it's initial catalog. We then want to specify the user ID, and I need to bring up my little Excel spreadsheet of what I called it, and I'm just going to paste that in. In my instance, that was Commander API. Putting some extra white space there, and then the last key you want is, no surprises, password. Now, red flag alert. I'm just going to type in my password. It's plain text, so everybody can see it. And if I then push this up to GitHub, for example, everybody can see it. Big no-no. In a development environment, you would use something called user secrets to squirrel those data values away so that you wouldn't see them here and they wouldn't get pushed up to GitHub. And in a production environment, you would use something like Azure Key Vault or something else to do that. I'm not going to cover that here, just in the interest of time. If you're interested in user secrets, again, you can Google it, or if you want to buy my book, I cover it all in that, both production and development, how to set up secure connection strings. But for now, I'm just going to specify my password in plain text, which is a password I only use for test stuff, so feel free to try and hack my online accounts with it if you want. You will not succeed. So password is password, I think that's correct. Cool. So I think that is everything we need to do. I don't think I need to put a semicolon in there, but I'm going to, as it's in my notes. So I think that's our connection string all set up. Cool. All right, so now what we want to do is we actually want to, again, start to tie all this together a bit more. It's still all very fragmented, so we're going to finalize this bit of setting up our database context. So where do you think we configure our DB context class for use within the rest of our application? Any ideas? Yes, for those of you who said startup, give yourself 5 gold stars and 1,000,000 points, correct. And what method do we configure it in? Correct. For those of you who said configure services, you are right again. Give yourself another 10 gold stars and another 3,000,000 points. You're doing really well. So we do it through our services collection, services, add DB context. And what type of DB context are we adding? We're adding a commander context. And then we want to supply some options through a Lambda expression. And we want to use SQL Server. Now it won't pick this up as we don't have the right namespace in. Now this is specific to SQL Server. So again, if you're using a different database provider, different package reference within your CS proj file, different format of a connection string, and at this point here you would use a slightly different syntax to add the provider for your database. So we're using SQL Server in this instance. And then we're going to pass in some config elements. So we're going to make use of the configuration API. Configuration. And when I was whittering on about, you know, being easier to get a connection string if we use a particular key within our app settings JSON file, this was what I was talking about. We can make use of this get connection string method, and then all we need to do is provide the name of the connection string in here, which was commander connection. Okay. So the code's a lot more readable, it's a lot nicer. If you didn't use this key here and you just called it something else, you would have to reference your config, again using the configuration API, but you'd have to do it in a slightly more long-winded way, which I'm not going to cover here. It's not that difficult, it just doesn't look as nice. So the only thing we really need to tidy up is just bring in the correct using statement to make use of use SQL Server, and that is using Microsoft Entity Framework Core. And that should work. So I'm not going to go into too much about this. I think this should be fairly obvious to you now. We're adding a DB context for use within the rest of our application through dependency injection, and we're just providing in some config, which is our connection string. So with that, we should have joined all the dots. We have a DB context, we have our database, we have our connection string, we've now registered it all together within our startup method. We should be good to go to move on to thinking about migrations. Okay, so just make sure you actually save your work. I've not saved the startup class there before we move on to anything else. So what are migrations? Migrations are really, they're just a list of instructions given to our database to allow it to recreate or create, if you've not done so already, a database schema that mirrors our internal representation of the data within our application. So in our case, if you look at our DB context class, we've said we want one DB set of commands, so our migration will basically replicate that desire down to our SQL Server, and as we've not run it already, it will create a database for us as well. Over time, as you make changes to your application and you add configuration detail to your model, and you'll see what I mean in a minute, your migrations will change over time, and you'll apply those migrations subsequently to your database to keep it up to date. And you can roll back migrations and all that kind of cool stuff. So enough talking, let's go on and do it. So I'm going to bring up the command line, and I'm going to basically use the .NET Core tools that I was talking about earlier on. So if you haven't got those installed, now would be a good time to do it. So .NET EF, migrations, add, and you give it a name, and try and make the name meaningful to the change that you're going to apply. So as this is our first migration, something like initial migration is actually totally fine. Maybe capitalize that. Okay, and capitalize this. All right. So what does that do? Well, let's hit enter and find out. Keep an eye over here. And what you should see is we have a new folder automatically created. Let me just minimize these so we have a bit more screen real estate, called migrations, and in here we have a number of files. Now the only one we're really interested in is this last one here, and that basically, kill this as well, are the steps that are going to be performed on our database to create our table down on the database. There are two methods, up and down. Up will create stuff, down will delete stuff, and it's used, the down method is used if you're rolling back migrations once they've been applied. So all we have done at this stage is create a migration file. We've not done anything on our database. If you have a look at our SQL Server, and we'll do a refresh, still don't have a database, don't have any tables, nothing has happened to our database yet. All we have done is create a migration file. I mean, I need to run that migration. Now, before we do that, just taking a look at the up method, you can see what's going to happen. We're going to create a table. It's going to be called commands. So if you'll remember, if we go back to our DB context class, we called our DB set commands. That is where that's coming from, okay? We go back over, where's our migration? Okay, it is. Don't know where that went, maybe it's off screen somewhere. And then you can see we are going to create a number of columns within that table. So ID is going to be not nullable, nullable is false. It's going to set something called a SQL Server identity with a seed of 1 and an increment of 1. So that means if you insert a row into our table, the ID column will automatically be populated initially with a 1, and then every subsequent insert will add 1 to it. And you can also see here we're adding a constraint to our table, and that is creating a primary key using the ID. Now again, when we created our command model, we used the name ID for our first property. This is this idea of convention over configuration, and Entity Framework Core knows that we intended that to be our primary key. So it did all this stuff for us without us having to specify anything specifically. Cool, so I'm happy with that. However, I'm not happy with these other elements here. So you'll see, again, if we go back to our model, let's have a quick recap of what was in it. We had our ID, how to, line, and platform. So over here, the migration is basically saying, yeah, we want to create those columns, that's all cool, but you'll see here nullable has been set to true for all of them, because we've not specified anywhere that these don't need to be null. So I don't think that's very good, because what's the point in creating an entry that doesn't have a command line snippet in it? There's absolutely no value. So what I want to do now is go, this migration is not quite what I want, and we need to change our model to reflect the validations that we require in our database to ensure that there's actually data there. So bringing back our terminal prompt, you can see here there was a little comment right at the end. To undo this action, use EF migrations remove. So I'm going to do that, and all that's going to do is just remove those migrations that have not yet been run. So EF, let's go .NET EF. Move that cursor out of the way so you can see migrations remove. Okay, so let's remove that. And all that will do is we'll just remove these migrations from our folder, and the folder will eventually be empty. It's not actually rolling back a migration, that's slightly different. Rolling back a migration is once we've applied it and actually implemented it in our database, we can roll it back. That's not what this was. This was just basically getting rid of a migration set that we had created. Cool. So you can see this has now been deleted, so we'll just close that down. So what we want to do now is revisit our model and actually rectify the issue that we had there. So let's kill that. Let's get rid of this. Let's get rid of this. Let's get rid of this. We shouldn't need those again. And go back over to our command model. Now, it's the simplest sort of type of class you could ever define. We're going to make it slightly more complex now. So we're going to create some room here. And what we can do to specify that our how-to column, and in fact our line column, and in fact our platform column are not null, is to simply decorate them with something called data annotations. And there's loads of these available, and you can get quite complex with it. But all we need to do is specify the required annotation. Now, we don't know what that is, so again, control period, and we'll bring in system component model data annotations. Now you'll see I'm not actually putting that on here because, again, convention over configuration, it knows that's a primary key, and by its very nature it's required and not nullable. What you can do is you can actually specify the key annotation. You don't really need to do that because it knows it already, but let's put it in. It maybe it sort of helps document the code a bit, but you don't really need to do it. Let's put required in for all the others as well. And you can get really complex with this. I'm not going to delve into it too much in this video, but you can get a lot more complex. One thing I do want to probably do is constrain, let's say, the length of the string, just to show you how that works. So you can specify something called the max length and then just give it a char count, 250, whatever. So you're not overdoing the strings that you're putting in. Again, that's just an arbitrary number, just to show you how that works. All right, cool. So we've updated our model. Let's rerun our migration or create migration command and see what our migration file looks like. So let's kill that. Let's bring up our command line again. Let's do an up key again, and let's run that one more time. Again, it creates some new migrations. The only other thing to note, there is a timestamp there. So again, that allows this Entity Framework Core to apply the migrations in the right order. If you have multiple migrations and you maybe wiped your entire database, you could run your migrations again and it would run all of them from the start in that instance. Or if you've rolled back, it will run them from the point at which you rolled back. And when we actually come to creating our database, there's a table in the database that actually has a tracker of the migrations that have been applied. Cool, so let's have a quick look at the file. And it looks very similar, but you'll start to see some new stuff in here, most notably for all of these 3 columns that nullable has now been set to false, which is good. So it basically means we require all that data. And for our how-to column, you can see here that the max length annotation has been added in as well. Cool, so I think that looks good for our purposes. So we're now ready to run this migration file and see, fingers crossed, if we've done everything correctly, that it creates our database and our table in our database that will hold our commands. So the way we run migrations in Entity Framework Core is .NET EF database, database update. Now this is when we'll all go wrong if we've not done things correctly, but let's see how we go. And fingers crossed. I'm confident that we have done everything correctly. And if not, I blame you. It's your fault, not mine. Joking, of course. So that might take a while to run. Shouldn't take too long though. So we need to make sure your database is up and running and all that good stuff. So looks like it's done. It's not complained significantly. So let's go back over to our database and let's do a refresh. Fantastic, you did a good job there. We're up and running. So it's created a database called CommanderDB, just to refresh your memory, back over in our connection string when we specified an initial catalog. That's where this value comes from. And then within our CommanderDB, we have, or we should have, a couple of tables. Indeed we do. So we've got this internal system table, EF migrations history. Let's right click and do a select top 1000 rows. And that will just show you the migration ID that was applied and the name of the migration and what product version it was at. So this is how it kind of keeps track of what migrations have been run. Cool, we're not going to use that again. And then of course our commands table. So let's do a select. There won't be any data in there. Cool, so that's all been set up correctly. So give yourself a clap, give yourself a round of applause. That's the same thing, isn't it? But good, so that's a big milestone. So the only thing I want to do now is actually add some real data to our table. Now look, there are a number of automated ways you can do this, and I have again detailed that in other tutorials, and I think it's in my book as well. In the interest of time, I'm not going to do that here. I'm just going to do a bit of a hack and just right click our commands table and do edit top 200 rows, and you get a kind of Excel like entry, not an entry form, but yeah, Excel type setup where you can just directly put data into the table. What better way to kick off our command line database than to just detail the 2 commands that we've already used to create migrations. So it's kind of like a meta type scenario. So the first one would be how to create migrations, and then the command line, let's just remind ourselves of what that was. There we go, copy that out, and we'll paste that in here. Now, again, it doesn't really matter what we're putting in here, but to be honest with you, I actually do use this in my in my real life, I've got a SQL Server database, not this one, another one that has a list of all these many commands for things like Docker and Entity Framework and Unix and Linux, and I actually use it all the time, so I found it useful. Maybe you will do too. Platform is EF Core. Let's capitalize that. One thing you'll notice is that we didn't put an ID in, and this is a concept we'll revisit a bit later when we come to creating resources through our API. The database created our ID for us, okay? And again, if we add our second command line snippet in, how to run migrations, database update, I think that's correct. Not quite, .NET EF, database update, that's correct, isn't it? My memory is absolutely shocking. Yeah, that is correct, cool. You'll see, actually we have to put in item there, you'll see it puts in an ID of 2. Something else, let's just try put some junk data in, and if we try and add that line, I just hit down key there, you'll see it will complain because we have a null value in our platform, and that is because our data annotations have been applied to the table. So let's just escape that. We only want 2 lines of data. Let's do a quick run, so select everything from commands. We can see we've got our data in our database, cool. Just going back to what I was saying about database design, if you right click the commands table, hit design, you'll see down here, I'm just going to order the attributes alphabetically. You can see a number of things that are in place. First of all, this identity specification, which was, you saw that in the migration file where we have the increment and the seed, 1 and 1. Is it an identity? Yes, so all good. You can see here it's a primary key. You can see here that nulls are not allowed on any of them. And you can also see the 250 character limit on our how-to column as well. So it all matches what we specified in our code has been migrated down to the database. So it's actually very cool and very powerful. All right, so we are basically done. If we just quickly have a look at our architecture again, in terms of this bit here, the data access class, our SQL Server database, and indeed our model now, I think I'm correct, I don't let me change our model again now. We are done, that's all locked in. But what we do need to do is now revisit our repository. And what do you think we need to do? Currently we're using our lovely interface, which is not, well, it's going to change because we're going to add more methods to it, but that's not going to change initially. What we're going to do is we're going to swap out the concrete implementation that it's using, which is currently our mock repository, and we're going to swap it out for a new implementation using our DB context. So this is where it starts to get quite exciting. We're going to use real data via our DB context and via a new concrete repository class. So why don't we go on and do that now? All right, back over in our application, we want to create a new implementation of our iCommander repo. Now, just before we do that, there was something that was slightly bothering me. I kind of renamed this wrong. It was just a slip, it was just a typo error. Instead of get app commands, it should be get all commands. Makes no actual difference to the running of our code, but it was just something that was annoying me. However, it illustrates a really interesting point. We've now just changed our interface, which is almost like our contract. And you can see now, because we've changed our interface, we now have multiple errors throughout our code. So it's a good illustration of how important it is to get your interfaces correct. So we'll just fix that up. So back over in mock commander repo, it's claiming we've not implemented the interface correctly, which is in fact correct. So let's just update that, and that should get rid of that error. And then obviously we're using a repository from within our commands controller, so we just need to update that. So a really useful illustration on, yes, just because you're using repositories and dependency injection, if you ultimately get the contract wrong and you change it, it will have ramifications. All right, so we don't need any of that stuff now. So yes, coming back to what we were intending to do, we want to create a SQL implementation of our iCommander interface. So select your data folder, new file, SQL commander repo.cs, namespace commander data, and then a public class called SQL Commander Repo. And what we're going to implement, we're going to implement our iCommander repo interface. And then again, straight away, it should start to complain. Why? Because we've not implemented the members yet, so let's implement it. And we get our placeholder stuff, that's okay. So let's implement our get all commands now, with the correct name that was really bothering me from before. So we want to basically make use of our DB context class to return our command items from our database. Where are we going to get a DB context instance from? Correct, we're going to get it from constructor dependency injection. So back over in our class, ctor to wire up our constructor, public SQL Commander repo is fine, and this time we're going to ask for not an interface, but an actual implementation of our Commander context. And we'll call that context. Now it should be resolving this because it's in the same namespace, Commander data. Commander, doesn't seem to like that. Because I've got 3 M's in it. There we go, a bit overzealous with the M's. And we are going to, again, following the same pattern, our dependency injection system is going to populate this context attribute here. We're going to pass that into a private read-only field called context. And it will complain, doesn't know what this is, so control period to generate a read-only field. Now again, this is a very similar pattern that you'll have seen before. Also, if we just pop over to startup, you'll see exactly the same pattern used in our startup class. This was the scaffolded code that we got, so it's used everywhere. So you'll get very familiar with this setup. So that means we now have an instance via dependency injection of our DB context class called context. So we want to literally just return what from our context? Well, you can see here we have a list of operations and methods and attributes, but the one we want is this DB set called commands. Fantastic. And we just want to return all commands to a list. Now it will I can say it will complain because we need to bring in the link namespace in order to do that. And it's literally that simple. So we've implemented our get all commands using our DB context, and it's just going to return a list of all the commands from our database. For our get command by ID, it's slightly more complex, not much more so, but we're going to return from our context class, and using our commands DB set, we are going to use the link command first or default, and then we're going to use a lambda expression to specify what we want, and we want something equal to the ID that we have passed in our method. So that's basically just getting the first or default member from our commands data set where the ID equals that. Fairly straightforward. Now, this is where the magic starts to happen. We've just implemented a SQL Commander concrete class that implements our interface. Let's look at how easy it is to swap out our mock implementation for our actual SQL implementation, and hopefully it should all work. So, just going to bring this back up again. I'm going to do a .NET build just to make sure we don't have any errors hiding anywhere. We should get nothing. Cool. So back over in our startup class, where do you think we make this swaparoo? No surprises. In fact, let's just comment that out so you have a reference point for it. Copy it back in. And instead of mock commander repository, we simply type in SQL Commander repo. That's it. We don't need to make changes to our code anywhere else. We've created a new implementation using SQL Server. Think you might want to use a different database, or you might want to use a different ORM, so not Entity Framework, something like NHibernate. You could create a class with that. You could have multiple ORMs via the same repository. It doesn't really matter. So very, very powerful. So all that's left to do, really, is to, let's build it again, but we should get no errors, and let's just run it now. And let me bring up a version of, an instance, should I say, of, I keep forgetting the name of this application, Postman. Use it all the time, forgetting the name of it. So let's just clear these already. Yeah. And that was another thing I was playing with. So localhost 500 API commands. And we get no response because I think we're using HTTPS there and it should be HTTP. So again, these are little gotchas. If we put in HTTPS, we can use port 501, or as I was trying to do there, just use HTTP. Let's see if that works. And in fact, no, it doesn't. It's still returning back our hard-coded repository. I wonder why that is. I wonder if it's because I've not saved the file. And indeed it is. Oh my goodness, that's going to drive me nuts. So make sure you save your work. I don't know how many times that has caught me out. Let's try it again. I'm leaving this stuff in. I could quite easily edit this stuff out, but I want to show you the mistakes I make as well. Let's give that another go. Actually, that's quite good because that was showing us what we were returning when it was using the mock. Actually, it's fortuitous. Try it one more time. There we go. So after saving our startup file and after having swapped out the concrete implementation that we're using, none of the other code has to change, but we're now getting data from our SQL Server. Whew. So that is another part of this tutorial finished. It's a lot of wiring up that was required, but yeah, we're there. Repository and DB context are looking really good. So now we're going to move on to another concept. We'll revisit our architecture and we'll move on to another concept around data transfer objects now. So yes, let's take a quick look at our architecture just to see how we're progressing along with the build. So I won't dwell on the things we have already covered. Basically, in the last section we set up our DB context class to access our SQL Server database using Entity Framework Core, and additionally we set up a SQL repository and implementation of our interface to use that DB context. All good. Still some work to do in that repository, but it's progressing well. Now our discussion turns to DTOs, and that's the next part of our architecture here. So I'm going to talk a bit about them, and it's basically, again, talking to this theme of decoupling implementation from contract detail. So let me I won't go through the rest of those animations, and I'll bring up this next slide. So this is our current state, and I've denoted our API or application as a black box. And what I really am trying to say there is, from a client perspective, it does not care what's inside that black box, how we've implemented it, whether it's C#, Java, whether it's using a SQL database. It doesn't care, and it shouldn't care. All it cares about is the contract that we have established with the client to say, this is the interface, the API interface that we are going to provide to you. And conversely, the client should be using that contract to make calls to our API. Otherwise, it may end up with some strange results. So it's a bilateral agreement, really. Now, at this point in time, our client will make a HTTP GET request to our API, and our API will return some serialized data to the client. And at this point in time, it's a serialized instance of our command class as an object. And I've got a representation of that on the screen there. So you may go, well, that all sounds perfectly reasonable. What's wrong with that? Well, what is wrong with that? Basically, we're exposing internal domain implementational detail back to our client. And what I mean by that is that we might be providing potentially irrelevant data back to our client. As it's low-level implementational detail, there might be attributes or properties within that class that we don't want to expose back to our client, things that are not relevant, things that are perhaps in the wrong format for our client to deal with. Maybe we have an internal representation of it and we want to provide it back in some other format to our client, or possibly even bits of data that are secure that we shouldn't be exposing to our client. So a very common one that's used is date of birth. We might be storing date of birth in our internal domain model, but we don't want to supply that back to our clients for obvious reasons. We might instead want to supply the age of that person rather than their date of birth. So at the moment, we're really just exposing our internal domain models back to our client. And that also means we are coupling our internals to our external contract. So on the last slide I was talking about providing a contract. Basically we've made our internal domain models effectively part of our contract with our external clients. So that means if we want to then change our implementational detail, change our domain models in some way, we're going to have to be very careful that we don't impact our contract, because that's the last thing you want, especially if you're developing APIs, and especially if you're developing APIs that are being consumed by public clients, even internal clients within your own organization. Still definitely a big no-no. Or, as I've said there, you may not care about that. You may just make changes to your domain models and break the contract altogether. Now, if you do that, your organization, or certainly yourself as an individual, probably aren't going to be in business too long if you behave like that. So it's a big no-no. So what is the answer? Well, at high level, we need to decouple our internals from what we send and receive, from our contract, basically. And that's where data transfer objects come in. So I've opened up our black box. I've denoted it by a dotted blue line that you should be familiar with now. And here is our command object. That is our internal domain model. What we want to do now is set up an external model or data transfer object that represents that internal domain model. Now, there could be a complete one-to-one mapping. It's still a valid use case to set up a command DTO class that's exactly the same as the command object, and you're just mapping all the fields one for one. You could do that, but more than likely you're going to not. There's going to be some differences between them. But the important thing is there needs to be a mapping involved. Now, we're going to come on a bit later when we come on to coding this to doing the mapping in an automated way rather than doing it manually, which you could do if you so chose to, but I'm going to show you how to use something called AutoMapper to perform that mapping. And what will then happen once you create this command DTO, it's a representation of command. That is what will get passed back to the client. And again, I've just put a bit of a representation on what that might look like on screen. And you'll notice, just for the purposes of illustration, I've removed the platform attribute from it. So maybe not the best use case, but what I'm saying there is that the platform attribute is not relevant from our consumer's perspective, so we're not going to pass it back as part of the DTO. And what it then means is you can then change your command domain model to your heart's content, so long as you map it through to whatever that eventually looks like to your command DTO, which should not change or not change much, then it's all good. Now, just before we go into coding, just taking it a little step further, and we're going to be taking this approach ourselves. This is the use case I've just shown on the last slide, and I was talking about reading data, so our GET requests or GET action results. And we're going to create a command read DTO, so a representation of our command model for reading. But you can take it further and actually create a DTO for the creation of data. And we're going to come on to doing that again later when we are posting to our API. So HTTP post requests, we will include some object data in the request body and pass that through to our API. We may, and in fact we will want to have a different representation or a different DTO for the creation of data. And I'll just mention the word primary key or ID field, maybe have a bit of a think about whether we would include that or not in our command create DTO. So I think with that overview, I think it was worth doing that on screen just to give you a bit of a visualization of what we are going to do. We're going to now move on to actually writing up and starting to implement DTOs. Okay, so we're back over in our application. We have it running from just previously, so I'm going to do a Control-C to stop our web server, and I'm just going to get rid of our command terminal there, just to give us a bit more space on screen. So what we're going to do first, and it's kind of similar to when we used Entity Framework, we need to add some new package references. So actually, we do need our command line because I'm going to use the .NET Core CLI to add them. As usual, let's go over and have a quick look on NuGet as to what packages we need to support DTOs. So we're going to use something called AutoMapper. Now, just a quick digression, we don't actually need to use AutoMapper to use DTOs. When we come on to actually mapping our domain model or command model to the DTO that we create, we could do that manually, okay? it's very error prone, and again, as the objects get bigger, it's just something you don't want to do. So this AutoMapper package, basically, as the name suggests, automatically maps your command objects to your DTOs, and actually vice versa. So when we come on to doing the create action, it'll map our create DTO to our model as well. So it maps both ways, and you can do some really interesting, clever stuff with it. We're not going to stress it too much. Nonetheless, it's a great tool, and it saves us a lot of time. So the package we're actually going to install is this one here, AutoMapper Extensions Microsoft Dependency Injection, and it has AutoMapper as a dependency. So we just need to add this. So again, I'm using .NET CLI. Let's copy that to the clipboard. Let's do a quick clear of the screen and paste that in. I could leave that in, that is the latest version, but I'm just going to take that out. And let's go and see what we get. So we'll go off to NuGet, we'll bring the package down, it should add it in to our CSproj file. So that all looks good. So to make use of our AutoMapper facility, again, where do you think we need to kind of start wiring up? That's right, of course, in our startup class. So let's move over there and add another service for use within the rest of our application. So over in startup, let's just move over here. I'm going to take this out now. I think you guys should probably understand that well enough now. You don't need that errant code lying around, so that's all good. So again, we're going to make use of our services collection, and yeah, we'll add the namespace later. So yes, this time it's going to be add AutoMapper, and it won't find it because we don't have the namespace, so we'll bring that in a minute. And the way that it needs to get created or instantiated, it needs to get the current assemblies within our application. So we access that by going app domain, current domain, and then get assemblies. Don't forget the double brackets and the semicolon, and as you can see here, it's having trouble resolving this, so control period to bring in using AutoMapper at the top there. And that's all we need to do, again, within our startup class, within our configure services method, to make AutoMapper available through dependency injection to the rest of our application. Fantastic. So that's the kind of wiring up done. Let's move on to actually using it and implementing it. So the next thing we want to do is actually create our DTO object. So that will require yet again another folder. So click out into the root space of the file directory, new folder, and we call it not dots, DTOs. Oh my goodness, DTOs. And in our DTO folder, we're just going to create our command read DTO. So new file, command read DTO.cs. And I'm going to cheat a little bit here. I'm just going to go over to our existing command model, and I'm going to copy all of this stuff from the namespace down. And I'm going to copy it into our command read DTO. I'm just going to change the namespace from models to DTOs. Make sure you do that. And the name of the class to command read DTO. Cool. Now I'm going to take out the data annotations because as this is a read DTO, they don't really make as much sense. You could argue that, yeah, I mean, it helps with the contract, I suppose, to understand what is required, what you can expect coming back, but for simplicity's sake, I'm just going to take these out for this DTO. We will inject them back in when we come to doing a create DTO. And just looking at that, that's probably about right. I'm just making sure I've named it correctly. Command read DTO, it's the right namespace. Now, as per the PowerPoint, and just for the purposes of illustration, we're going to take out this property here, the platform property, and we can do that under the guise that it's implementational detail that we don't need to expose to our client. I would argue that it's probably quite a useful bit of information, but it's just for illustration. And that's basically our DTO created. Now, what we have at this stage is we've got our command object still, our domain model, and we have our DTO. Now we have to tie them together via a mapping profile. So let's do that now. All right, so I'm just going to kill a few of these things I don't think we really need to reference at the moment. We'll leave our command read DTO and our command object up there. And yes, as I said, what we want to do is create a mapping profile that maps our command object to our read DTO, so that when we pass it out, that's what's going to get mapped. And we require yet another folder in our root, so click out anywhere and new folder, and no surprises what this is going to be called. We're going to call it profiles. And we're going to create a profile file for each of your domain objects. So we're going to create one for our commands, so we'll call it commands profile. Make sure you put it in the right folder, not in properties. So create file, commands profile .cs. Okay, fantastic. And we'll just declare our namespace, commander profiles, not there, profile ILI. Awesome. And we'll just declare a public class in here, and we'll call it commands profile. Awesome. Now we want to actually inherit from a base object called profile, and that is available through the AutoMapper namespace, so control P to bring that in. And then all we simply have to do is create a constructor for our class. Commands profile is perfectly fine. We don't have any parameters for it, but what we are going to do is use this create map command to map between a source object and a destination object. So what we're mapping from and what we're mapping to. So create map, we're going to map from our command object, singular. Probably should have named this project something different, it's quite annoying. And we're going to map it to, what did we call our DTO? Command read DTO. We're going to map it to command read DTO. Cool. Don't forget the round brackets. So it's complaining, or it doesn't know what that is, so using DTOs, and similarly using models. And that's it. Now these create maps can get a lot more complicated if you're concatenating data or joining data or putting rules in or something like that. We're just going to make use of it from a fairly simple level, and all that's doing is basically looking at both objects. AutoMapper's smart enough to just map things straight across. So don't forget to save that. So now we're going to actually come on and we're going to revisit our commands controller and use AutoMapper to return back a DTO rather than the internal domain object. Okay, so let's move over to our controller now, and I'm just going to do a little bit of tidying up of our code, a little bit of refactoring. Well, it's not really refactoring by taking out a comment, but I'm going to take that out anyway just to clean it up. I'm going to leave these in for the moment because it might prove useful when we come on to doing our other action results, but I'm going to return that to being a sort of variable ID in our route. And the only other thing I want to change is this action result here a bit. It's not really adhering to our specification, and by that I mean if we call this with an invalid ID of a resource that doesn't exist, it will return, I believe, a no content error code. We don't want that. We want a not found error code. So let's just run it and test current behavior in Postman. Bring up Postman. I don't want to start Outlook. Don't want to do that. Kill that. Postman. So let's get a valid result. I think I was just playing with this before. Yep, so we have a resource with ID 1 in our database. If we pass in an invalid ID, or one that doesn't exist, we get this no content. So we actually want to return a not found instead, as per our spec. So let's close that down, and it's also slightly nicer code as well. So back down here, we're still going to continue to do this, but all we're simply going to do is check whether this is null or not. So if command item doesn't equal null, then we're going to continue to do this. Otherwise, we'll just return a not found. So save that off. Let's bring up our command line. Let's rerun it. Excellent. And let's try this again. So we'll do a 1. It should bring back a 200 OK. Fantastic. And if we do a 4, it should bring back a not found, 404 not found, which is much better. Cool. So let's stop this. Let's kill that. And now get back to what we were wanting to do, which was use AutoMapper. Now, quick question for you. We want to use AutoMapper from within our controller class. How are we going to get an instance of our AutoMapper object? Well, of course, constructor dependency injection. And so the way you add more services into your constructors, you just simply add them as another argument into your constructor. So this time we're going to ask for an iMapper object, and we're going to put it in something called mapper. Now it's going to complain because we're not using AutoMapper. We are now. And then we're going to put it into a private read-only field called _mapper and make that equal to mapper. And yes, you guessed it, control period, create a read-only field. Just the same pattern again and again. So hopefully this dependency injection, constructor injection is starting to look pretty good and pretty straightforward. So we're going to now use this mapper object within our read or get action results. So let's do our get command. It's been a long day. Get command by ID action result. Now, the first thing I would draw your attention to, currently this action result is returning a command. Do you think we want to return a command? No, we don't want to return a command. We want to return a command read DTO. So let's update that and let's bring in the relevant namespace, command DTOs. So that's the first thing we want to do. And then within our return method here, everything else is going to stay the same. We're going to use our repository in exactly the same way, and we're going to bring back a command object. But what we are going to do is not return back the command item if one is found. We're going to return back a command read DTO that's mapped from the domain object. And the way we do that is by making use of our mapper instance and then the map method here. And what we're going to map? Well, we're going to map into our command read DTO type. That's what we're putting data into. And where's that data going to come from? I'm sure you can guess where it's going to come from. That's right, it's going to come from our command item. And I think that's probably it, to be honest with you. So why don't we give that a go and see what we get. Now, just before we, well, let's run it up first. Command run. This is going to test a number of things to make sure we've wired it all up correctly. So back over here, if we call a valid endpoint, a valid resource, we do indeed get it, but you will notice that the platform element has disappeared and we are actually getting our DTO back. Give yourself a round of applause. It's incredibly exciting, I know. And to do it for our other action result, where we're returning a list of objects, it's very, very, very similar. It's not much different. Instead of returning an enumeration of commands, we are going to return an enumeration of command read DTOs. And instead of returning that enumeration of command items, let's get rid of that. We're going to make use of our mapper. We're going to map. What are we going to map? We're going to map an IEnumerable of what? Of command read DTOs. And where is the data coming from? It's coming from our command items that we've returned back from our repository. And that should hopefully stop complaining. It would help if I copied the full thing, command items. Fantastic. Let's save that off. Let's run it up again and see how we're going. I'm feeling positive about this, I hope you are too. And bring up Postman again, and let's bring back all our commands. And again, we've only got 2 in there, but you will see that we brought back our array of objects minus the platform attribute. That's DTOs, that's read DTOs anyway. We are getting very, very close now, and in fact we've pretty much, with that, we've really set up all our plumbing. It's taken a really long time to set up a repository, set up our entity framework core stuff, set up our automapper stuff. Now we've still got to add bits for our other actions, but in terms of a base level wiring up of everything, we're pretty much done. All we need to do now is return to our controller and our repository and start building up our other action results. So just a quick application architecture check just to see how we're traveling. I'm just going to skip through the stuff you're already familiar with. So we covered DTOs just in the last section, and in fact, based on what you're seeing here, we've actually implemented all of our architecture, and as I just mentioned, we still have other gaps to fill in, but the overall architecture, we've pretty much covered everything now, and all that's really left is to come on to looking at the remaining endpoints we need to implement. And the next one we're going to pick off our list is our ability to create resources in our database. So let's start with that and how. So back over in our application, let's just shut down our web server. Let's get rid of our command line. Now, we've covered a lot of stuff, and if we're going to introduce another action result, you kind of go, where do I start with this? And there's a number of places you could start, but I'm going to start with our repository interface. And I feel that we need to specify a new contract item in there to denote our ability to create something ultimately in our database. So let's go back into data. Let's go back over to our iCommander repo. And let's add in a new, effectively, contract item that's going to denote our ability to create something in our database. So we're going to have a void return type. We can come back to why I'm doing that later, but void return type for the moment. And we'll call it create command. And what will that take? It will take a command object as its input, and you can call it something like CMD. Again, that's simple. Now, we are actually going to add another interface item in here, and we're going to call it save changes. So make it a bool this time, call it save changes, and it doesn't actually take anything. Now, what is that? Well, let's park that for the moment. Just trust me on this. We're going to need something called save changes. We'll cover it in a bit later. So let's save that off. So that's all we need to do for our command repo interface. We've specified two new methods. One's quite obvious, one is not quite as obvious, but we'll come back to what that is in a minute. And straight away, you can see that our mock repository and our SQL repository are complaining. Why? Because we've not implemented the interface. Now, at this point, you can leave the mock repo here, or you can delete it altogether. It's entirely up to you. I'm not going to do anything particularly amazing here. I'm just going to implement the interface, and it will just throw these not implemented exceptions. That's all I'm going to do. For me, I quite like having a mock repository hanging around in case I do want to use it. So rather than deleting it, I'm going to leave it there just now. Save that off, and then we come back to our SQL command repo, where we actually do need to provide some implementational detail around that. So as usual, control period, I don't think that worked. Control period and implement the interface. And where did it put them? Okay, create command is here and save changes is here. So let's do save changes first. It's a really simple one, to be honest with you. All we're ultimately going to do on our DB context, we're just going to call a method save changes. And what that actually does is whenever you make a change to data via a DB context, the data won't actually be changed on the database unless you call this method. So we're going to use other methods on our context, like create and add, I think it's add, delete, remove, all these kind of things. But until you call save changes, that won't then be replicated down in your database. So we need to implement that method here. And we did say a return type of bool, so let's sort that out. Return, put it in brackets. and greater than 0, I think. Greater than or equal to 0 should suffice. Okay, cool. So it'll become clearer when we actually come on to using it. Okay, so we want to move on to actually doing our create command, which is a bit more interesting. So let's get rid of that. And the first thing we want to check is to see if the command passed in is actually equal to null, and if so, we want to throw an exception. Where the hell did that come from? I don't know. So throw new argument null. Oh my goodness. Exception. And we'll use this name of construct to return the name back. And it's going to complain about this. I think I spelled it wrong. Argument, ENT. There we go. And we need to bring in system namespace. Cool. Now, if it's not null, then what do we want to do? It's actually really very simple. On our DB context, on our commands DB set, we want to call add. What do we want to add? We just want to add the command. Now, this is what I'm talking about, what I was talking about previously. Simply adding the command to the commands DB set on our context is great, and it will actually be tracked within our DB context. But unless you then call save changes on the context, that data won't be flushed into the database. Cool. So that's pretty good. We've updated our iCommander repo with 2 new contract items, and we've updated our SQL Commander repository with actual implementation for our SQL Server. As far as our mock repository is gone, we've not implemented that, but you could if you want to mock that up. That's maybe an exercise for you to look at yourself. Okay, so what do we want to do next? Let's take a quick look at our architecture. And we're trying to pick one that's not animated. I think they're all animated. That one, open up. So we don't need. So we're talking purely about implementing our create action on our controller. Where do we need to focus our attention? Our model's good. We don't need to do anything with our model. Our controller definitely needs to have a controller action result in there. So perhaps we look there. Data access DB context. We don't actually need to do anything with that. It already had that add method built in, so that's all okay. Our repository is done. Cool. DTO. So we did mention that when we make an API request to create a resource, we're going to expect some body text in that request that will map to a resource that we want to create. So in my mind, I think that's probably where we should go next, as it's a more foundational element. So let's go and create our command create DTO and have a bit of a discussion around that. So back over in our application, I don't think anything's running. It's not. Cool, let's get rid of that. So this is all looking a bit busy. This is why I don't really like running in a low resolution, but it's definitely easier to read when you're on a mobile device or something. So don't need to do anything more in our data folder. We do want to have a look, as I said, at our DTO folder, our DTO space, and we want to create a new DTO. So select that, new file, and we will call this command create DTO.cs. And let's just copy this through and paste it in here, and we will just change the name to command create DTO. Now, looking at our model and looking at the items that ultimately are going to be required in the database somewhere, these 3 fields are all required. So if we're going to attempt to create a resource in our database, we need to supply all of those. So in our read, we're not supplying it back, but I'm going to copy it and I'm going to paste it into our create DTO, because we will get an error if that is not supplied. Now, coming back to this, we obviously require an ID, a primary key. It's absolutely mandatory. Should we be passing it over from our client application to our API? In this instance, the answer to that is no, because our ID, our primary key, is actually being created by our database. It's taking care of that. So in our create DTO, we don't want to be supplying that as an input. It's not needed, it's not relevant. The ID doesn't exist before it's created, and it's going to get created by our database. So with that in mind, we take it out. Now, just coming back to our command model, in our read DTO, we took out all of these data attributes, data annotations. I'm going to put them back in for our DTO because, well, you'll see, actually, let's leave them out for the moment and let's see how we go without them, and then we'll reintroduce them a bit later. It's probably a better way to demonstrate it. So for now, command create DTO has been created. We've taken out the ID we don't need, and we've reinserted the platform attribute into our create command DTO. So let's save that off, and let's think about how we're going to use that now. So back over in commands controller, there's actually a surprising amount of work to do to get a create action to work. So maybe we just have a quick peek back at our definitions here, if I can find them. There we go. So we are implementing this one here. So look at the route, it's API commands, which is fine. We don't really need to do much with the route. The verb is going to be post. We're going to create a resource. If we're successful, we're going to return a 201 created, and we should actually return back an instance of the created object as well, which I've not really got on this slide here, but that's what we need to do. So that adds a bit of extra complexity, and we have some failure cases here that we'll deal with a bit later. So back over in commands controller, let's begin writing up our next action result. So before we even do that, let's, following this kind of syntax here, what verb are we going to use? We're going to be using post. And what's the route? API commands. That's it. We don't supply an ID because the ID doesn't yet exist. So that's just a comment, obviously. So we will decorate our action result with HTTP post. So that makes it now unique within our controller, because although it responds to the same route as this one, it's using a different verb. Fantastic. And public action result. Now, as I just said, we're going to create a resource in our database. If it's successful and it gets created, cool, we're going to return a 201 success code back, but we're also going to return a representation of that model. And what's the representation of that model? Remember, we're reading. It's going to be a command read DTO. So it's a little bit counterintuitive, because we're going to be creating a resource with our platform attribute, and then when we get it, seeing it being created, it's going to return back our command read DTO without the platform. Nonetheless, it helps kind of enforce the principles I'm trying to teach you. So back to this action result, what is it going to return? It's going to return, that's right, a command read DTO. And we are going to call it, you can call it anything you like really, but let's call it something meaningful, create command. And what we're going to expect as an input, a command create DTO. And we'll just call that command create DTO with a small c. Wonderful. Okay, so hopefully that method signature makes sense. We're using HTTP post. It's an action result, obviously, and what is it returning back? It's going to return back a command read DTO. We've called it create command, and it's going to take as an input a command create DTO. Cool. So ultimately what we're wanting to do is we're wanting to put whatever we get in our API request body and convert it into a model so we can actually put it into our repository. So first thing we need to do is make use of AutoMapper to create a command model. And we're going to make use of mapper, and we're going to map. Now, we have a little bit of an issue. We did, if you remember, create our profiles folder here, and we created this mapping here, where we are mapping, and maybe it's actually worth putting in some commentary here, source to target or destination. So in this instance, we're think about reading, think about only about reading. We are reading a command from our database and we're passing it back to our client So the source is our command, the target is a read DTO. So we've created a map that way. We're now kind of slightly flipping it on its head, and we're expecting what? We're expecting a command create DTO, and we need to map that to a command domain object. So that actually requires another create map command. So create map, command create DTO this time, and what we're mapping that to, we're mapping that back to a command. Assuming I can spell it correctly. Okay, so hopefully that made sense. So anytime you're doing a translation one way to the other, you have to explicitly declare it here. Just because we had that, well, in fact, we're mapping to a completely different DTO, so you have to be explicit with your mappings is what I'm saying. So let's save off our commands profile and let's get back to our command controller, and this map operation should work now because we've told Automapper about this mapping via our profile. And so what do we actually want to map? We want to map to a command object. And what is the source? Our source is this command create DTO. So we could perhaps do some kind of validation check on this before it comes in. I'm not doing that just for the purposes of brevity. So again, just to reiterate, we want to get a command model because we're going to put that into our database, and that's what our database understands. In order to do that, we need to map whatever's passed through in our request body and map it into a command, and we're using Automapper to do that. So that's that bit of translation there. And then simply all we need to do is make use of our repository and call the create command method on that. And what does that expect? That expects a command, so we can pass in command model. Fantastic. Now, just to prove my point, actually need to return something here in order for it to work. So let's just do a return. Let's just do this for the moment. Just to get our command working, because we're going to build this up in a few steps. So I want to take it one step at a time. So I just want to get this working. This is not the final code. I just wanted to stop that complaining. So let's save that off and let's test that from our client and see how we get on. So just before we actually do attempt to test that, make sure you've saved your work, and we'll do a .NET run to run it up. Now, one thing I do want to say is we were saying that we're expecting it to pass back a command read DTO, and we're actually passing back a command model. It probably won't complain about that. It will actually pass back the command model, which is not, of course, what we want. But again, I just put that in just as a temporary measure, just to get this working and see what stage we've got to with this action result. So our web server is running. Let's move over to Postman. And we have an old existing GET request where we're pulling back this resource here. What we want to do is switch this, actually, let's just make sure that's still working. It is, fantastic. So we want to change this to a post request now. We want to make sure we have the right URI so it doesn't have an integer at the end of it. And we want to add in some body text. So this is where the new object is going to be placed, the serialized object. Now I'm sure you won't mind, but I've got some JSON over here that I'm just going to paste in. It should look very familiar. It basically represents our command create DTO with a how to align in a platform. Make sure that the body is set to raw and the data type is set to JSON. Now what we should expect, well, it should be, is a 200 to get returned, which is not what we want, and an object created in our database, and that object passed back. So let's send that now. So we're getting a 200 OK. It has returned back a full command object with an ID of 0, which is kind of interesting. So let's see whether that was created in our database or not. So back over in SQL Server, let's do a select everything from commands, execute it, and there's nothing there. Let's, well, of course, if we actually tried to do a GET request now, we only get, of course, we're only going to get those two objects. So why was that? Well, for those of you who are keen of eye and understood what I was prattling on about a bit earlier, what we actually didn't do was call repository save changes. So we called our repository create command, it added it to our DB set, but it didn't persist the changes down to the database. So now by saving the changes, we should get an object created in our database. So let's try that now. Don't forget to save your work, and then let's try that again. Okay, so back over in Postman, let's switch this to a post request, raw and JSON, and let's send this over. Okay, so we're getting a 200, which is not what we want, but that's cool. And we're actually getting an object returned back, this time with an ID of 4, which ultimately we don't want. Actually, we do want that in our read DTO, but we don't want this platform attribute here. Anyway, we'll cover that off in a minute. That's looking more promising, so why don't we test it from our API rather than going directly to the database? And let's just get a list of all our commands. And what you should see is, in fact, yes, we have a new resource with an ID of 4 that was created by our database, and that is now in our database, obviously. Okay, so good, we are getting there, but we still are having that issue that when we created the resource, we just put in a temporary measure to return back a command object, which is not what we want. We want to return back a command read DTO to maintain our contract as we have specified. Now, the other thing that REST also requires is when you return a resource like that, not only should you return the resource, you should return the URI to where that resource can be found. That's part of the sort of REST specification, if you want to call it that, which if you look at the headers of our return type, we don't have anything like that either. All we got back was, actually we need to look at the other, let's do a post again, let's send that. So again, we've created a duplicate entry, it's got a new ID, that's cool. If you look at the headers, there is, while we got the resource back, we didn't get a URI to where that resource exists, and that's really what you should be doing. And we should be providing a 201 response, which is created. So let's fix that up now. Right, so let's get rid of that. Let's stop our web server from running. So we are getting there, but at the moment we are returning back a full-on command model, which is taking us back to the issue we had right at the start, and we want to pass back a command read DTO. So how do we do that? Well, it's something you've already seen before, and if I go up here actually let's type it out because it gets you used to the syntax rather than me just pasting stuff in. That's not any good, is it? So what we want to do is we want to create a placeholder command read DTO. And we'll just make that equal to mapper, and it's going to map to what? The command read DTO. And where's the data coming from? Quite simply, it's coming from here, our command model that was created in our database. So you will recall we did actually pass that model back. Let's fix that up. We did actually pass that back to Postman last time, so it was created. So we're just going to use that data and map it to a command read DTO. Let's just do this iteratively. Let's paste that in here. And let's try that again. So let's do a run. Go back over to our model, post, make sure that we have something in here. Let's put in how to, actually let's just leave it, doesn't matter. We're going to have duplicate data, that's okay. Let's send that. What did we get returned? If we go to our body, yep, so we've got a resource with an ID of 6, that's cool, so 200, and we don't have a platform attribute there. So cool, we're now returning a command read DTO, cool. So we're getting closer. We need to change this to a 201, and we need to also pass back the URI of this resource, which is part of the REST specification. So let's just kill the web server. And we're going to not make use of this return OK, and we're going to make use of something called created at route. Now it looks a bit cumbersome the way it's written, so I'm going to write it out first, and then I'll explain it as we go. Now, before I even do that, we're actually going to, as part of that created at route operation, we actually need to make use of this existing action result where we can retrieve a resource from our database. Now, in order to make use of this, we have to actually name it. And you simply put that in here after the other attributes that we have, and we just give it a name. Name equals, and I'm just going to give it exactly the same name as the method name. Now, I'll be totally honest with you, I've had some issues with this. My understanding is you shouldn't need to actually explicitly name it, and you should be able to use the name of operator just to get the method name. I've had some really weird behaviors with it, so I'm going to follow this convention because this way works, but just be aware there are a few gotchas with this and haven't quite got to the bottom of it. One of them I experienced a while ago was to do with asynchronous methods, which is a whole other story, and I'm not going to cover that here. All our methods are synchronous. That's fine for the purposes of this video. So anyway, long story short, we're actually going to make use of this, but in order to make use of it, we need to explicitly name it, and the name is just exactly the same as the method name. Hopefully it'll become a bit clearer when we now come on to doing what we're going to do. So we are going to return, and we're going to make use of created at route. Now there's created at action, created at route. I'll cover off the differences between those in a blog article at some other point later, but for the moment we're going to use created at route. So what do we expect? We expect the name of our method that retrieves a single command resource. So I'm going to pass that into here. Then we have to create a new anonymous object, which is effectively our command object. ID equals command read DTO ID, and then finally we pass back our command read DTO. So as I said, it's a little bit convoluted, not very nice. Let's just test it to see if it works and gets the result that we expect, and then I'll take you through what each of those bits means. So save this and let's run this up. And let's go back to Postman. And I think everything is set up as we expected. We're going to have lots of duplicate resources in there. Obviously their IDs are going to be different, but the content's going to be the same. We can tidy that out later. So yep, everything looks good. Let's create send. Excellent. So we get a 201 created. Fantastic. We get our resource returned as JSON. Fantastic. And you can see here we were previously getting 4 headers returned. We're now getting a 5th header with a location in it, and this indicates the URL to the resource basically. And you can see here, yes indeed, there's the full URI to our resource. So let's just copy that, and we should be able to take that, paste it into our Postman instance. Make sure you change the get verb, and I'm fairly confident if we click send, we actually get back, if we go back to body, we get back the resource that we just created. So that's a really important part of the REST architectural principle. If you create a resource, you need, not only do you have to pass it back, but you also have to pass back the location of where it was created. So I did promise you that I would explain the created at route method a little better. So just to refresh your memory, let's just stop this and get rid of that and kill this. This was our created at route method here. So rather than me trying to explain it from the ground up, why don't we let Microsoft do the hard work? It's here on the Microsoft documentation, and it basically specifies what it was doing. It creates a created at route result with a 201 created with the specified values. Now the values we passed in were the route name. This is the name of the route used to generate the URL. So going back to our code, this was basically our action result that returned back a single resource. Okay, so that generated that URI. Popping back over, we then give it the route values. This is the route data used to generate the URL. Cool, so that's basically the number 7 in that instance. And then finally the content value to format the entire body. And again, that's just our command read DTO. Alright, so it's a little bit unintuitive. Again, there is a created at, what is it called? Created at action method as well. Take a look at that and look at what the differences are between the two, but for now we are going to leave that and move on. Just before we do though, give yourself another round of applause because we've now implemented 3 of our 6 action results. So let's just take a quick sense check of where we're at actually in terms of the entire video. We're really moving through this, so let's come back to our overview. We've done the introduction, we've done the coding part 1, we've done our entity framework stuff, we've done our data transfer objects, and we have now just finished our endpoint for creating resources. So really, we've only got one more bit to go, and that's doing updates, patching, and deletes, and then we're going to wrap up and do some final thoughts. So well done for sticking this far. We're almost there, but we've got a bit more to go. So just before we actually move on to doing our update action results using put and patch, I do just want to circle back to our post action result with regards to the creation of data. So I just want to show you something very quickly, and hopefully this will make sense as to where I'm going. Here is our Postman instance. Let me just make sure our application is running. I think I might have stopped it. Let me run that up again. And there are no data annotations on our command create DTO, nor are there on our command read DTO, so there's no annotations on them at all. We do have annotations, i.e. that all these fields are required at the domain model level. Okay, so that's both valid at a domain model level and also then when we replicate that required schema down to our database, it's there as well. So what happens if we don't supply one of these attributes when we try to create a request? Now, according to our DTO, that's totally fine. There's no data annotation or constraint there, but there is a domain level. So let's just send that and see what happens. And okay, I need to make sure that this is on screen. We get a 500 internal server error and a whole pile of exceptions. And you can see here it's actually an exception from Entity Framework saying there's a DB update exception. And basically what's happening there, you can see here, column platform, you can't insert a null value into it. So that's definitely not a good state of affairs to have. Now, it's entirely possible that a client using our API, and this goes back to talking about contracts, may supply data like that to our client. And we definitely don't want to throw a wobbler and throw a 500 internal server error, because what that's saying is the server's made a mistake, not the client. And in this instance, it's actually the client that's made the mistake, not our server. Well, it kind of has. So we need to fix that up. And the way we do it, it's actually really simple. We just employ data annotations within our create DTO. So let me just stop this for the moment. I don't really need to copy. It's actually fairly self-explanatory. Let me copy this one because it's slightly more complex. And let's go over to our command create DTO. And let's apply those same annotations to our command create DTO. Now what this is going to do, it's not going to solve the issue of whether a client does or does not pass something through. We have no control over that. Let's just bring in the namespace. But what it will do, it will throw back a 400 type error code saying, you've made a mistake, not us. And it looks a lot nicer, and it gives some detail around to the client about what the problem is, rather than throwing a stack trace back at them, which you wouldn't do anyway in a production environment. So let's just save off our command create DTO. Let's run up our web server again, and let's try that one more time and see what we get. So let me make sure that's on screen, send that through. There we go. So we get a 400 bad request this time. That's much, much better. And you can see here you get some nice JSON error code returned back, and it tells us what the error is, and there could be multiple errors within there. And in this instance, the platform field is required. So the client can then read that and understand what's going on rather than just throwing a horrible stack trace back. So I just wanted to, I actually forgot about circling back to that. Glad I remembered. So yes, very important that on our create, and we're going to actually create an update DTO that you put data annotations in there, because it makes error handling from a client perspective much, much nicer, and it also doesn't make us look bad by throwing back 500 bad requests or server error codes. Cool, so I think with that we can now actually finally move on to our update action results. Okay, so we move on to implementing our put endpoint, and that is one of two update endpoints that we're going to create. So put is our first one, excuse me, and patch is our second one, and I'll cover off obviously what both of those are. So before we go on, at this stage now I wanted to get us into a bit of a rhythm, so I've put together a plan of attack on how we will tackle all three of our remaining endpoints, so what we need to do in the code and how we should tackle it, just to kind of get us into a bit of a rhythm. So this remainder of the video should be relatively quick, I hope. So I'll give you an overview of what a put request is and how it's different from a patch request, how it's called, so we'll just go over and have a look at a mocked up example in Postman, what success code we should expect back, and then this is our plan of attack. So we'll update our repository interface to reflect the need to perform an update action. We will of course then need to implement that in our SQL repository. We'll then create a command update DTO, and then finally we'll go into our controller and we'll actually create the action result that responds to a put request. So what is a put request? Well, it's a full update. So by that, what I mean is you need to supply the entire object, even if you're only wanting to update one of the attributes in it. So for example, our really small object has 4 attributes technically, including the primary key. So even if you only wanted to update the how-to text in our object, you still have to pass through the other 2 attributes as well, even if you're not updating them. So those values would stay the same. So it's really, really inefficient, and of course error prone. So for large objects where you've got 30 or 40 attributes, you've got to make sure you pass the exact same object back over if you want it to basically remain the same, except for the changes that you're making. And you might only be making a change in 1 or 2 of the attributes. So inefficient over the wire, it's error prone, especially for larger objects, and it's actually not used so much now. Patch is the favoured approach, where we can do partial updates much easier, and I'll cover that of course later. But I'm including it because it's the traditional way of updating, and I feel you should be across how that works. And for your purposes it may be fine, and for this project it's actually kind of okay. Okay, so let's just quickly pop over to Postman, and I've got a mocked up request here. Let me just move that out of the way. So as you will have seen before, we have the sort of standard URI where we need to supply the ID of the resource that we want to update. So that is obviously important, that we need to tell the API what single resource we are updating, and we supply that via the URI. And of course the verb that we set our Postman instance to is put, and these two things taken in conjunction are unique. So coming down to the body text that we supply, one thing you'll notice straight away, and you might ask the question, where's the ID field or the ID attribute? I did mention you have to supply the whole object. That is true, but as the ID is our primary key and it's not going to be updated, you can't update it, then we don't need to really supply that. In my previous video, I think I did supply the ID. It's not really needed, to be honest with you. So you only need to supply the object that have updatable fields, and ID is not one of them, and we're also supplying it in the URI. Everything else we need to supply, and if you remember what our create payload looks like, it looks quite similar because of the way we've structured our data validation. So we'll talk a bit about that later. In terms of a successful return, you would most usually, when you successfully update call the API endpoint to perform an update, you can either return a 200 OK, and you can possibly supply back the object that's been updated. I have done that in the past, but more usually what you typically do for a put request is to supply back a 204 no content response, and it's then the client's responsibility to go, okay, that was successful, and if they actually want to check that the object has been updated, they can call the respective endpoint to pull back the data. 2 methods. We're going to, for the purposes of brevity, we're just going to return a 204, and that's probably what you're more likely to see out there in the real world. Okay, so I think that's enough of an introduction. I think now we need to move on to actually coding up our put action result. Okay, so let's just minimize this and move back over to our code project. Maybe just check to see if the web server is running. No, it's not. Fantastic. So as per our plan of attack, the first thing we said we were going to do was update our interface for our repository. Now, just before we do that, I just want to reiterate the point that when we're defining our interface for a repository, it's agnostic away from implementation. So when you're designing any interface, you should be thinking about not, I'm going to be implementing that using a SQL Server and Entity Framework Core, or I'm going to be implementing that using Automap, or I'm going to be implementing that using whatever technology. It's agnostic from that, and you should really just be thinking about, from a theoretical perspective, what should this interface provide? So, logically speaking, we're going to be creating updates. Our API is going to be responding to update commands. It happens to be using HTTP to do that in this instance. Doesn't actually need to do that, but we're doing updates via our API. So it makes kind of sense to think, well, our repository interface should provide some update functionality. So why am I going on? Why am I laboring this point? You'll see in just a minute why I'm laboring this point. So it makes sense that in our interface, we should be providing the ability to update a command. And we're just going to follow a very similar, not exactly the same pattern with the exception of the name, to the upstairs signature. Cool, so all good. So when we come over to our mock repository, it's complaining. So again, you can delete this if you want. I'm going to leave it in there because I'm going to post the code up to GitHub thing down below so you can have a look. The code's all there fully, so I'm leaving the mock repository in. You can take it out if you want. Now we move on to our SQL Commander repo, and just to refresh your memory, our SQL Commander repo is an implementation class using a DB context. Okay, so we're starting to actually need to think about how do we implement our interface methods. Now in this case, because of the way DB context works, we don't actually really have to have an update method in here. But we need to have it in here because we need to implement the interface, but we don't need to really put any code in here. And I'll show you when we come on to actually doing the update why that is the case. So rather than throwing an exception, we're not throwing an exception, we are going to quote unquote implement it by doing nothing. Okay. Now it may be that if you then switch out this implementation for another one, you may need to actually implement your update method. Okay, so it's a little bit counterintuitive, but again, interface and implementation are divorced from each other. When we think about an interface, we should be thinking generically and theoretically about what we should be providing. When we come to implementing it, well, in this instance, we don't actually need to implement anything because it's taken care of by the DB context within, well, you'll see when we come on to doing it. Trust me on that. So basically, that's us done. Make sure I'll save the interface as well. So we've updated our iCommander repo, cool, and we've updated our two implementation classes, even though we don't actually need to do anything in there. Fantastic. Okay, so I think the next thing we wanted to do, as per our plan of attack, was come on to doing our DTO. I think that's right, wasn't it? Yep, SQL repository, yep, command update DTO. So let's go on and do that now. All right, so we want to update or add a new DTO for update. Now, let's take a quick look at our command create DTO. I'm just going to move that up, it's annoying me. And basically, as per what we sort of mocked up in Postman, we need to supply the entire object. We don't need to supply the ID. And if you look at our command create DTO, it's absolutely identical. So technically speaking, we could just use this in when we come to doing updates as well. I'm going to actually create a new file, a dedicated file, and I'm just going to duplicate the code, which is very inefficient. So a bit of homework for you is to figure out, yes, let's have a command update DTO. So I want to have those separate artifacts with the separate definitions, but how can we make the fact that the command create DTO and command update DTO are going to be absolutely identical aside from their name? So I'm just going to be a bit lazy, just copy that in, and I'm going to update the name to update. I'm going to leave the validations in as before because they are still, of course, valid. I'll save this as well. But yes, we've got two absolutely identical classes now, which is not good design at all. But the interests of time and just to test you a little bit, I'm going to set you the challenge to, yes, maintain those two separate classes, but how could we make it a bit more efficient going forward? And the reason we're having two separate classes is that we may want to, in the future, change how we update and create stuff, possibly. So we're building for the future. So that's it, very simple. Command update DTO is an exact copy of command create DTO. If you want to figure out how to make that slightly more efficient code in line with good object-oriented practices, I will leave that with you. Alright, so that stuff is done, and now we come on to the more exciting part, which is actually to implement our action result. Okay, so I'm just going to close down some of this stuff just to give us a bit of breathing space and minimize these. So yes, we need to move over to our commands controller and add in our new action result. So we have 3 existing, we are adding our 4th in now. So we are definitely moving through the video. I'm just going to put in this documentation at the top again, just to help contextualize what we are doing. So again, put verb, and this is the URI that we are going to expect our endpoint to be called on. So not surprisingly, we are going to decorate our action result with the HTTP put attribute. And also, as we're expecting an ID, then we need to specify that here as well as part of the route. And that should look familiar from one of our previous action results. Fantastic. Now, as I said, we're not returning anything back from this action result. We're just returning a 204 no content. So as such, we specify our action result without a return type. And we'll call it update command. Now, we are going to expect through the int ID that's going to come from our route. That's going to be bound from our route. And then we are going to also expect a command update DTO, which will come from our body text. And we will work with that DTO as we move through the action result. Cool. So the client is expecting us to update a resource. The first thing we should check to see is whether that resource actually exists or not. So let's do a quick check first. So we're going to create a placeholder variable to hold that. So command from repo, let's call it command model from repo, just so we're clear what it is. Although it's coming from the repo, so it's kind of inferred, I guess, but let's leave it at that. So we'll use our repository. We will call our get command by ID to return the requested resource from the repository and put it into here. And of course, we want to check to see whether this is null or not. I seem to be a bit trigger happy with the M's. Command model from repo, if it's equal to null, then we just want to return not found, a 404 not found. Cool. Otherwise, it means we have something and we want to update it. So what we really want to do is we want to take the data from our command update DTO that's been supplied by our client and actually apply it on top of our command model from the repo. Now, in order to do that, you're probably going, don't we need an auto mapper mapping in our profile? Do you know what? You'd be absolutely right. We do, in fact, need that. So let's go over to our commands profile and let's create a map. And what are we mapping from? We're mapping from a command update DTO, and we're mapping it across to our command. So that should hopefully make sense. We've covered AutoMapper, I think, quite a bit. So our source is our update DTO from our client, and we want to apply that to our command object that we have retrieved from our repository. So in order to use that, we're going to call our mapper, and we're going to call map on that, and we're going to call it in a slightly different way. But previously, we were mapping from data to a new or empty object of some type, be it a DTO or a model. So for example, when we were performing a retrieve from our repository. When we used the mapper, we were mapping from a model that had contained data to a new empty command read DTO. For our post command, we were using map twice. So in the first instance, we were mapping from that we're going to do here actually from a command create DTO that contained data, and we were mapping that into a new quote unquote empty command object. Here we have a command update DTO that has data, and we have a command model from repo that both contain data. So we're going to use a slightly different syntax. It's actually a bit simpler. We specify the existing source object, which in this case is our command update DTO. That contains the data that we want to map from. And what do we want to map to? Our command model from a repo. Fantastic. So that basically maps the profile that we've set up here, and because the fields are exactly the same, AutoMapper does its business. Now, coming back to the fact that we have no implementation in our SQL repository class, this mapping exercise here has basically, what it's actually done is it's actually updated this model, and those changes are actually being tracked via our DB context. So we don't actually need to do anything else with it other than save changes. Okay, so our data has been updated in our context, but we still need to flush it down to our database. We don't need to do anything else with our repository. However, in the interests of maintaining a separate interface from implementation, good practice is to still call the update method on our repository and supply in our command model from repo, because other implementations may require that you do that. So we're still going to call repository, we're going to call update command, and we're going to pass in this command here, which is intuitively probably something that makes more sense. You would expect the update command in the repository to take our new data that's been mapped through and push it down. We don't actually need to do that just because of the way Entity Framework works. And what this means is if you then switch out your implementation for something else that does require this, you've already got the code there and you don't need to perform any code changes within your action result. It's a little counterintuitive, but it is good practice. And then what we really do need to do is then call save changes on our repository, and that will flush down the changes that were actually made at this step here back down to our database. Let's just save that. And then the last thing we want to do is return no content, which is a 204. Cool. So a little bit possibly counterintuitive. You may want to remark this out, but that's kind of against the whole point. You may as well just take it out, leave it in. It's benign, it's not really doing anything. And then if you do come to change your implementation, as I say, it's already there. Okay, so I think with that, that's our action result for our put request completed. All we need to do now is test it to make sure that it works. So let's, before we do anything else, let's do a .NET run. And that will pick up any build errors, so you don't really need to do a .NET build in addition. That all looks pretty good. Okay, fine, so we're up and running with that. Let's just minimize this and let's bring our Postman back up. So before we do that, let's just return back all our resources. And I need to just, excuse me, just play about with this window. And yes, there's all our resources. We'll pick one that we want to update. We've got quite a few duplicates in here when we were playing with our create last time. So let's pick number 5. Currently the how to run a .NET Core app, and the line is .NET Run. So let's update that. Let's set that to put. And I've already kind of pre-qualified this with how to roll back a migration, so it's relatively useful, and we'll supply everything across. So let's send that over, and we're getting a bad request. And let's see, what's it saying? Bad request. Invalid with JSON string. String should be incorrect. String should be correctly escaped. What have we done wrong here? Okay. There we go. String should be correctly escaped. It's pretty good, that, isn't it? Let's try that one more time. There we go. So we get 204, no content back, which is fine. Let's request that from our other action result, and we can see here, yes, in fact, it has updated how to roll back a migration, and it's updated the line as well. And we're not getting the platform back because we're using the command read DTO. Cool, so that all looks like that's working, and as you saw, we hadn't formatted the JSON correctly, it complained. Let's just take this out, and we'll make sure we format the JSON string correctly. So basically what we're saying is we want to do an update again on that same resource, but we're not going to supply all the attributes that it needs, so it should definitely complain. Bad request, fantastic, and it should tell us the platform field is required, so all good again. And then let's just test something random. We don't have a resource of 45, and it's returning back. Okay, it's interesting. It's actually doing the validations first, so let's put that back in. And let's send that again. And it's giving us the 404. So it's doing the validations first, and then once the validations pass, it's then returning the 404. So that's all good. It looks like our put request is working as per our specification. So time now to move on to the more interesting patch request. So let me just bring up my amazing PowerPoint slide that I know you all love so dearly. So patch endpoint, plan of attack. It's very similar to the last one. I'm contradicting myself here. There's less work but more work, if that makes sense. So I'll give you an overview of the patch request, how it's called, the use of a patch document, which is really important, and again what we should expect back. Spoiler alert, it's exactly the same as the put request. We're going to return 204 no content, so that's covered off. And we'll then of course create a patch action result in our controller. Now you'll notice there's no mention of an update to our repository class, and there's no need to create a separate DTO, which we don't actually need to do. So sounds like there's less work to do, but there is in fact some groundwork, quite significant, no, not significant. There's a bit more groundwork we need to do to just get the patch request stuff up and running, a bit plumbing required. Anyway, before we do that, let's just cover what the JSON patch standard is. I'm not going to do this in laborious detail. If you want to read about it, it is specified in RFC 6902. But what you should be aware of is that there are 6 operations. Now at a high level, patch request, I should maybe take a step back, allows you to do partial updates. So before you saw we had to supply the entire object, not very efficient. What patch allows you to do is pick certain attributes and do certain things with those individual attributes, such as adding new attributes to your object. Now we can't do that because we're using a static object. I may do another video on dynamic objects, which is definitely outside the scope of this. That's what the add would do, it would add new attributes to your object. Similar with remove. Replace is the one we are going to be using the most. So basically we'll be supplying a path to an attribute. We'll supply a value, and then we'll call the replace operator to replace the existing value with a new value. Copy and move are self-explanatory. Test is really supplying a path to an attribute and a value, and the test is basically, the test operator is to see whether the existing attribute matches the supplied attribute. So quite a useful one. So here's an example of a patch document that we're going to send over. So we're not going to send over the JSON that we had sent previously for our update request. We're going to send something like this. So it begins as an array, a JSON array, which is square brackets, and then we will supply our first operation. And you can have multiple operations within a patch document. So you can see here, the operation is denoted by the key OP, and then you tell it what you are wanting to do, and that's one of the 6 operations that I just mentioned the last time. The path is the path to the attribute you want to look at, and you can supply nested attributes if your objects are more complex than ours. And then the value is basically the value you want to, in this case, replace the existing value with. On the example here, we are performing a test, so we're looking at the line attribute in this case, and we are testing to see whether the value is .NET new or not. Couple of points: all operations need to complete successfully in order for the patch request itself to be successful, and if they're all not successful, then none are successful. That's it. Okay, I thought I had more notes there. That's about it. So all good. So yeah, just to reiterate, patch request is partial updates. We supply over, it's like a change set or patch document with all the step changes that you want to perform on your resource, as opposed to just providing everything. So much more efficient. It's used more widely now, and definitely if you're doing API stuff, you really should be providing a patch action result or API endpoint, which is what we are going to do now. All right, let's clear this down. Now, as I mentioned, there's a little bit of pre-work. We have to install a couple of packages basically in order to get the patch stuff working. It doesn't come kind of out the box with what we've already got. So let's just kill our web server. We'll leave our command line running as we need to install a couple of packages. Let me just clear this down. And let's open up our CS_proj file so you can see our existing packages in there. So I'm going to pull up NuGet again, and I'm going to show you the first package that we need to install. And you'll excuse me if I don't type it, and I'm sure you're sick of seeing me do that. The first package is ASP.NET Core.json patch. So probably a relatively simple rationale for why we need to include that. It's basically ASP.NET Core support for JSON patch. So let's not waste any more time about explaining what that's doing. It's basically giving us the support that we need to include patch requests in our API. So as before, copy that in, and it should be added into our CS_proj file. That's all good. Now we do actually need another package, and this is all to do with how we serialize and deserialize data. And we're actually going to make use of the Newtonsoft JSON library, but it's not the core library, it's one that's specific to MVC. So this is the one we want, Microsoft ASP.NET Core.MVC Newtonsoft JSON. And yes, this is required as well, and I'll call out in the code where this is specifically being used. And we actually do need to do in order to use it, actually we do need to do a bit of setup in our startup class as well. So let's just copy that and let's paste that in here too. And I'm going to not use the preview version, use the latest version. And that's gone in as well. So just double checking, we have got our ASP.NET Core JSON patch and our ASP.NET Core MVC Newtonsoft JSON packages. Okay. I think we can close our command line down now. So, and close this down. So as I said, in order to use that second package, we do need to do a little bit of setup within our startup class. Now the first thing I'm going to do is I'm actually just going to include the using statement that we need rather than pulling it in automatically, just so that when we come to actually writing the code, it kind of auto-populates and it's just a bit of a more seamless experience. So we want to include Newtonsoft JSON serialization. So when we come to using it now, it just all auto-populates, and we need to just append some configuration onto the end of our add controllers method here. So what we need to do is add Newtonsoft JSON to this. We're then going to use a lambda expression to perform some setup, curly brackets. S goes to serializer settings, contract resolver, and then we're just going to set up a new, I think it's camel case, yes, camel case property names contract resolver. Bit of a mouthful, and again I'll call out when we are actually making use of this piece of wonderful config. It's a bit cumbersome, to be honest with you. I think they need to make this a little more intuitive and a little more out of the box, which I'm sure they'll do in subsequent editions of the framework, but I don't really like this, to be really honest with you, but nonetheless, this is what you need to do to get it all working. Okay, so that's that bit of pre-work done. There is a little bit more pre-work that we need to do. I mean, it's not huge, but I will, well, ruin the surprise for you. We basically have to add another create map within our commands profile. And this time, it's a create map the other way from our command to our command update DTO. And again, I'll call this out when we are making use of this in our controller. But what I think is worth pointing out is that just because you set up this map this way, so from a command update DTO to a command, it doesn't automatically mean that you have this mapping set up the other way. You have to explicitly set that up here too. Okay, which kind of makes sense because we're talking about a source and a target. So we're saying this is the source, this is the target. We have to then explicitly do it the other way. All good. So that's a bit of pre-work set up. We can now move on to our commands controller and actually get on with the business of writing up our patch request. Our patch action result, should I say. Okay, so let's just do our documentation. So patch, API, commands, and we are also expecting an ID. So the signature is exactly the same as for put, except from the verb that we're using, of course. And again, we're passing back a 204, no content, so our action result doesn't actually need to return any object data or have a return type. So public, where did that come from? Public action result, and we'll call this partial command update, as we're only going to be partially updating it. Hopefully makes sense. And again, we're going to expect the, now I've just forgotten something. Before we do this, let's move back up here. We need to decorate this with, what do you think? The HTTP patch attribute, of course, and we need to supply in an ID. There's a few times I've forgotten to do that, actually. It's got me into some trouble. So yes, before we declare our action result, we need to decorate it with HTTP patch. Fantastic. So yes, what prompted my memory was we are going to expect the ID to come in from the URI, which we get from this. And instead of expecting a command update DTO, we're going to expect something slightly different. We're going to expect a JSON patch document of type command update DTO, and we'll call that patch doc. Okay, and we'll just put some curly brackets in here. Now it doesn't know what this namespace is, so we will, I think I've typed that in wrong. I have. Document, let's try that again. Yeah, so using Microsoft ASP Netcore JSON patch. So that was the first package that we had added in. That was required to drive this. So yes, we're expecting a JSON patch document, and you supply the type, which is a update, command update DTO. Cool. Now, in exactly the same way that we did up here, we are requesting at the end of the day to update a resource. So the first thing we should actually do is check to see whether that resource exists. So I'm just going to copy this code. I hope you don't mind. At this stage, I'm sure you don't, and it's exactly the same. We just want to make sure that the resource is there. Cool. So just to step back again, what we are receiving from our client is this patch document that we want to apply ultimately to our command model, but we can't apply it directly to our command model because this is an update DTO patch document and this is a command model. So what we actually need to do is we need to, in order to apply the patch, we need to create a new command update DTO effectively. So we'll call it command to patch, and we will use AutoMapper to map to our of type command update DTO. And what is the source? The source is our model here. Put that in here. So what that's effectively doing is it's creating a new command update DTO with the contents from our repository, and it's putting it in command to patch. So that is making use of, just to step back here, it is making use of this mapping that we just put in. So the command is our source and we're mapping it into a command update DTO. Okay, so that's why we needed to put that in. Then this is where we actually make use of our patch doc up here. Patch doc, and it has this apply to method on it. And what do we want to apply it to? We want to apply it to our command to patch that we've just created here. And then we need to make use of something called model state. And this is where we required that other package to come in, because without that this would actually not work at this point in time. And all the model state is doing, well, the name's quite self-explanatory, it's just making sure that the validations are valid, basically. But we do need to do a quick check, so we need to do a validation check on that. So if try validate model, command to patch, then we return the validation problem, and we pass back this model state that we used above. Cool. So basically, we get our patch document from our request, we check that we have our resource to update from our repository, which is a model. We then need to generate a empty or a new command update DTO. We use the data from our repository model, and then we apply the patch to that. And we do a bit of a validation check to see whether it's all good. If so, cool, we progress on. And this should actually start to look fairly similar now. So what we then want to do is we basically want to update validations check. So we actually want to update our model data in a repository. So it's a similar concept that we had from up here. In fact, we can just copy this here. The only difference will be that we are not mapping our command update DTO, we're mapping this command patch DTO. So our validation is passed on this command update DTO, and we're now applying it to our model again. Our DB context has basically, it's tracking the changes of that model, so it's changed, but we do, or we should, call our update command again, our redundant update command. It's not really doing anything at this stage. With our command model from repo, this has now been changed, and then as before, we are calling save changes on our repository. And as before, we're going to return a no content back if we're successful. So hopefully that made sense. This is probably the new stuff that compared with the put action result above, where we just apply the patch document and validate it. Otherwise, it's pretty much the same. Okay, so I think that's looking okay. We'll find out if it's not when we come on to testing it now. Alright, so let's get a command line up and running. Make sure I select the correct screen, and we'll do .NET run to get our web server up and running. Cool. No complaints, so that's looking good. So let's move over to Postman to test our patch results. And the first thing I want to do is let's just get a list of our existing resources, and we'll pick one as a target. How about this one, number 7? No, not number 7, we've been playing with that one. I've been playing with that one, it looks like. So let's pick number 6. So run a .NET Core app with a line value of .NET Run. So to test our patch result, let's get rid of that body text. I hope you don't mind, I have one offline here, off to the side here, that I'm just going to paste in. And you'll remember from the PowerPoint, we started with some square brackets to denote a JSON array, and then we can list any number of operations. So here I'm specifying just one operation. It's a replace operation. The path is to our how-to attribute on our, well, what did we say? We're going to do 6, so let's just put that in there. So, well, all the how-tos are the same, but it's going to, no, this one here, it's going to change this how-to attribute to some new value. And we can change that to our heart's content. And yes, obviously we need to pass in the resource ID up in our URI. And finally, we need to set this to patch. I think that's all good. I think that's looking good. Yep, let's hit send. And we get 204 no content returned, which looks good. And let's retrieve our resource to see if it's been changed. So path should be some new value. And indeed it is. So well done, we've done a successful partial update. Give yourself a round of applause. Let's just see if we don't supply a value, what happens. The validation checks should kick in and we should get some nice JSON back saying you've not supplied enough data. So let's try that. Not forgetting to switch that back to patch. And indeed we get a bad request, 400 response, so client mistake and one or more validation errors. And it tells you what the error is, so that's all good. And of course, if we put something in where we don't have an ID, then we get a 404 not found. So that looks like our patch result is working as well. So yeah, give yourself a round of applause, 5 gold stars and a smiley face sticker. It's possibly the most complicated action result of our API, so well done, we've got that done. So moving on to our last action result now. It's actually, I think, arguably one of the simplest ones. We don't need a DTO or anything like that. It's our action result to delete resources. So let's wrap up with that last action result. So you'll be gutted to hear that I don't actually have a PowerPoint slide for our delete action result. It's quite simple, and I think we are at a stage where you don't need that now. It's a fairly self-explanatory action result. So just thinking about our plan of attack and how we would tackle it, the first thing we would look to see is whether we need to update our Commander repository to include to include a delete command, and indeed we do. And we'll pass in a command that we want to delete. All good. So it's our repository updated. You'll see that our implementation classes are complaining, so let's just implement the interface. Whoops. Here, we won't do anything with mock repo, and then in our SQL Commander repo we will implement that, and we will actually do something there. Fantastic. So, although it's probably not strictly necessary because we kind of check to see whether the command was, we will check to see whether the command or the resource is present in a repository from our controller. We'll double check it again here as well, and then we'll use our DB context to go to our commands and then remove our command. And again, we will, after calling this, we will again have to call save changes to flush those changes down. So that's our iRepository interface done, the Commander repo interface done. That's our concrete classes updated, fantastic. There is no need for a DTO as we are just passing in the resource ID in the URI. So let's move over, not to our commands profile, to our commands controller. And yes, there is no mapping as there's no DTOs. So let's move back over to our commands controller for our final action result. Now, like with the patch and put requests, we're going to return a no content. In the past, I have actually returned the JSON object of the deleted resource back when I've called the delete. You can do that if you want, but it's not necessary. So let's just do our final bit of documentation, delete, and the URI's API commands, and we are passing in an ID. Cool. We're going to decorate our action result with the HTTP delete attribute, of course, and we are again expecting an ID to be passed through. Cool. Partial. Public action result. We're not passing back any data, so we're just going to call this delete command. And all we're actually going to expect to come through is an integer of ID that we will use to delete. So in a very similar way, like we have done with put and patch, we are going to check to see whether the resource was found or not. If not, we'll return not found error code to our client. Otherwise, if it has been found, then all we really need to do is go to our repository and we need to call our delete command, and we just pass in our command object that we want to delete. In this case, it's our command model from repo. Cool, and then don't forget to save the changes. Fantastic, and then we return no content. Fantastic. All right, let's save that off and let's move straight over to testing it. Bring up a command line and up key to .NET Run It. All good, and let's move over to our Postman instance. Let's do a get all of all our resources, and let's select a target to terminate. How about 6 and 7, because they're kind of junky ones now. So we will select delete. We'll put in the ID of 6. We don't need any, select none there actually. And let's send that. Cool, so we get no content returned. Let's try and get this resource. We get 404 not found, which is absolutely correct. And well, that's basically it, to be honest with you. Let's just get a list of all our commands and we can see that yes, poor old number 6 resource has disappeared. So with that, we have completed all our action results. Let's just take a very quick look at everything we said we were going to implement and bring it up. Yep, so we have done, I think we've done all of that. We weren't going to implement this last one where we deleted a collection of resources. It's probably a bit too powerful. There's nothing wrong with doing it, but yes, let's leave that there for today. That was a long video, much longer than I had anticipated. So if you made it this far, congratulations and thank you. As usual, if you've got any comments or questions, please leave them in the comment section below and I'll be delighted to read those and answer as many as I possibly can. If you liked the video, please give it a like, and if you've not done so already, maybe think about subscribing. You'll be notified whenever I put anything new out. For those of you watching on Patreon or who have signed up to my Patreon channel, massive thank you to you as well, and your names will be appearing at the end of the video by way of a special thank you and shout out. Until the next time, I'm wishing you the very best of health and happiness, and to your families as well, and until the next time, stay safe and I'll see you around.